Yes, my dear friends. Good evening to all. Am I audible, visible? Everything is fine. Tell me, everything is fine now. Everything is cleared. Just 1 minute. Yeah. Clear है ना सब? Good. So, my dear friends, yeah, very good evening to all. And yeah, sorry for a little bit delay. Right. Okay. So, my dear friends, today I am going to discuss another important subject. And this is what? Material science. This is the third highest number, or you can say scoring subject. First is obviously production, another one is industrial, and third we can expect the material science. Mostly question last year we can see at least 8 to 10 question was from the MS material science. So it is more important. And yes, my dear friends, as I earlier promised you in the classroom also that I will come with the marathon of the material science. So here in this session I am going to cover all the important segment, and one thing I want to make sure, my dear friends, no question will be asked beyond that. Whatever concept, whatever content I am going to be cover here, you will find the question in that from only from that segment. So don't worry about that. Okay, question will not be same, but concept will be the same. Be assured about that, right? So that was the thing. Let's start now story. Okay, so right now, just 1 more minute, I'm waiting for. Right, fine. So my dear friends, here I am going to cover the whole material science. And before starting session, one thing I want to tell you again. Tomorrow, and tomorrow is I think what 18th of December, right? And your exam is on the when 20 December. So tomorrow I am going to take the mock test. Mock test means it will be same as I am going to take the same question, same level, which actually you will feel or you will find in your actual exam. So tomorrow don't forget to join at 5 p.m. also. In the starting I have told you, right? It will be the mock test, same pattern as BEL going to be conducted. Timing will be same at 5 p.m. right? Yeah, it will be live mock test. Yes, tomorrow at 5 p.m. Okay, now my dear friends, I am coming to the content here. We can see, right? Material science 130 question I am going to take, and I will discuss all different types of question here. I have taken the question here from the engineering material here, property of the material, and after that crystal structure and crystal defect, LY of the element, iron carbide diagram, triple time temperature and transformation. Okay, that all variety of question I have taken here. Testing of materials, so all different types of question that can be formed. With that I have came here. Okay, and you see here 130 question to you. I think 130 or 131 question is there, and all variety of question I have covered here. And one thing again I want to tell you, everything will come in that segment, don't worry. And I will share the learning content also today, especially this iron carbide diagram is most important. So I'm planning to take their learning content also. So I will take here learning content also. So meanwhile, just keep patient, take a bottle of water and start practice the question. That is the first question on the screen, and this question from the crystal structure. Question is coordination number of, this is the first question. Write down the question number answer. Coordination number of the FCC crystal structure 4, 6, 8 and 12. What will be answer of that question, my dear friends? 1. A for apple. Who is given A for apple? Apple is long answer, my dear friends, right? एप्पल नहीं हो सकता ना यार. 4 किसका होता है? चलो गलती करने का भी एक लिमिट होता है. हाँ, 4 तो किसी का नहीं होता है. Yes, keep in mind that will be 12. 8 किसके लिए होता है? Can tell me for which material 8? किसके लिए 8 होता है? 8 FCC. 8 किसके लिए होता है? Coordination number. You can tell me. So keep in mind that thing, right? Coordination number. What do you mean by coordination number? ये अपने अगल बगल कितना एटम को टच कर रहा है ना, अपने जो अगल बगल कितना एटम को टच कर रहा है, ये उसका कोऑर्डिनेशन नंबर बताता है. कीप इन माइंड. Next, that is another question. What is the packing factor of FCC crystal structure? And some option you have. What do you mean by packing factor, my dear friends? Packing factor means a unit cell you have, how much portion of unit cell has been covered by the atoms. मतलब किसी भी यूनिट सेल का कितना पार्ट एटम के द्वारा कवर किया गया है. That is going to be tell by the packing factor, right? Yes, I think what answer you guys are going to be give here, everyone? C for Chennai, 74% or 78%, my dear friends? Are you confusing? 74? Yes. So here see, I have come with the in simple cubic packing factor जो होगा 52% होगा, in SCP 74%, in body centered 68%, and face centered it is 74%. So keep in mind hexagonal and FCP have same 74%, or you can say 0.74 of packing factor. The meaning is that if you have a unit cell, this is your unit cell, right? Let's assume this is your like that, it is your unit cell, na? So here 74% of the part has been covered by atoms. That is the meaning of packing factor. How many percent is white? Just you can remove that -1 we can say, and you will get the white. What the crystal structure of alpha iron? Yes, body centered cubic structure, FCC, or you can say the hexagonal closed pack. What is the, tell me anybody, what will be the answer of अल्फा आयरन? अल्फा आयरन इज कॉल्ड फेराइट. जो रूम टेम्परेचर पे हमें जो मिलता है उसको हम अल्फा आयरन बोलते हैं, राइट? आयरन का कितना फेज होता है? इन आयरन कार्बन डायग्राम आई विल टीच यू after 1 hour. Here I will take the session in the same session here. So you know alpha, beta, beta is not there, alpha, delta and gamma, right? 3 phase. So out of which alpha phase is coming at the room temperature, it exists at room temperature, and their centered is what? Their structure is BCC. What about gamma iron? Gamma iron is FCC. What about delta iron? This is again BCC. Keep in mind all that thing. This is for the gamma iron, my dear friends, right? This is for gamma iron. BCC will be for delta iron also. So anything they can ask, try to remember all that. Well, come to the next question. I have came with the coordination number, and yes, my dear friends, try to remember that one. That is very, very important. I will share the PDF. Remember, in the most of the exam I have seen, they are going to ask what is the relation between A and R. Sorry, in most of the exam you will find. So please remember that. Please don't forget. Okay, in case of hexagonal closed pack, R equal to A by 2. In case of face centered cubic, A upon 2 root 2 R. R is equal to A upon. In case of BCC, A root 3 upon 4. That is a relation you have to be remember. Various times I have seen they are going to be. In case of simple cubic, in simple cubic simply we can say A equal to or we can say the R equal to simply A by 2. This is in the simple cubic also. So try to remember that value, right? Fine. Come to the question number next. The crystal structure of gamma iron. Now I think everyone can answer that question. The crystal structure of gamma iron, BCC, FCC, hexagonal or cubic structure. What will be gamma iron, my dear friends? Answer fast. Write down the question number and answer your fast. Do fast. Lot of things you have to be covered today. Even I have to be covered, learning content also of the iron carbon diagram. So this is called face centered cubic. And again, I want to tell you, my dear friends, all the question in exam will find from that one. Concept will be same. So this is face centered cubic. As usual, it is going to ask in the exam. Come to the next question. Effective number of atoms per unit cell in FCC structure. Effective number of atoms 4, 6, 8 and 12. What will be effective number of atoms? Effective number of atoms. What effective number of atom you know, my dear friends? What is the exact number that you can find in a unit cell? जैसे देखो ये यूनिट सेल है ना दोस्त, सिंपल करो, हमारे पास ये यूनिट सेल है, राइट? तो मान लो दिस इज वन ऑफ आवर यूनिट सेल. तो एक एटम यहाँ पे है, एक यहाँ, एक यहाँ, एक यहाँ, यहाँ लाइक दैट. तो आप देखो ये जो एटम्स है एक में कितना है, तो 1/8 पार्ट है. अगर मैं सिंपल क्यूबिक की बात करूं, सो सब कॉर्नर पे है ना 1/8 इंटू 1 हो जाएगा, तो 1 आ जाता है इन सिंपल क्यूबिक. Similarly, if you talk about face centered, so at all the face 1 will be, this is the face, this is the face, this is the face, and how many face? 6 faces are there. Yes, my dear friends, that time you guys are going to give A for apple, right answer, maximum. ठीक है? This will be. Now tell me, what will be the effective number of atoms in simple cubic? It will be 1. Simple cubic, it will be 1. What will be in case of BCC effective number of atoms? Anybody can tell me? Then comment. Simple cubic 1, BCC 4, FCC 4, and VCC will get 2. So keep in mind that thing. Effective number of atoms. Next question. Delta iron occur at temperature. Where delta iron you are going to find, my dear friends? Above the recrystallization temperature, above the melting point, between 1400 and 1539, between that. Okay, I will see this in iron carbon diagram. Meanwhile, try to remember delta iron we can find between the 1400 to 1539 degrees Celsius. In that you will find the delta iron phase, right? So try to remember that thing. Here, my dear friends, I have given the percentage of carbon. Here you can remember that also. Even I will see their learning content, so don't worry. Next, this is again the question from the iron carbon diagram. A steel with 0.8% of carbon is called hypoeutectoid steel, hypereutectoid steel, eutectoid steel, or none of these. What we can say? What will be answer 7? Question number 7 on your screen. Hypoeutectoid steel or hyper. Hypo, in day to day life you used to use the term hypo and hyper. Hyper means ज्यादा, नहीं बोलते हो यार हर बात पे hyper हो जाता है. Hyper means ज्यादा, hypo means कम. So here we can say 0.8% of carbon. So ये कम है, right? So what will be the answer? Right. Is called is what? Simply at the 0.8 na eutectoid steel. Good. Less than that it will be hypo, more than that will be hyper. This is the next question. The property of material which enable it to resist fracture due to high impact load, due to the high impact load, is known as brittleness, ductility, toughness, or hardness. Tell me what will be answer of that question, my dear friends. Hardness, the property of material which enable to resist the fracture due to high impact load. Here it is talk about the impact load, na? Brittleness, ductility, toughness, or hardness. Hardness, चलो मैं आपको एक lifeline देता हूँ. Hardness is not the right answer. Now give the answer. This is your just like a lifeline, okay? Okay, brittleness is also not the right answer. So what could be? Right, this time toughness. And ना, बोलता हूँ ना toughness क्या है? This is a one times of strain energy which is going to store the energy before fracture, and especially it play a major role if the load is impact. So it will be the toughness. C for Chennai is the right answer. Good. That is the next question on a screen. Slow plastic deformation of a material under constant stress is known creep, proof deformation, gradual deformation, or fatigue. Slow plastic deformation under a constant stress, that is the keyword of that question. Stress is constant, that means load is not going to be changed. This type of failure is called what? Creep, proof deformation, gradual deformation, or fatigue. Yes, my dear friends. See, if A for apple is the right answer, इसको हम creep बोलते हैं, right? Even you can observe. Constant load है, load is not going to be changed, but after a long interval of time, if the temperature is elevated, there will be change in length we can observe, and that is called basically creep, right? So A for apple is the right answer. If you talk about fatigue, fatigue में क्या होता है? How you can define the fatigue? The direction of load is going to be changed, or either their magnitude or direction, or both can change with respect to time. So it is called fatigue load. And my dear friends, fatigue load is very dangerous for a material. Fatigue load, which in case of fatigue load, the life of any object always will be very, very less than that of their yield point, right? And here, yes, you are going to define the endurance limit for the fatigue load. So keep in mind here it will be the creep. A for apple is the right answer. Well, good. That is the next question on the screen. The unique property of cast iron is high. What property of the cast iron is high? Malleability, ductility, toughness, or damping characteristics. What the property which unique or which is high for the cast iron? Right. इसीलिए आपको टॉम में पढ़ाया गया होगा, यू माइट हैव बीन, कि जब कभी भी हम अगर मैं लेथ का जो बेड को कंस्ट्रक्ट करते हैं, दिस इज मेड बाय द कास्ट आयरन. व्हाई? बिकॉज दे हैव ए गुड डैम्पिंग कैपेसिटी. आपने पंपिंग सेट अगेन भी देखा होगा, यू माइट हैव सीन that the foundation of the machine basically going to made by the cast iron, because once they start or moving there is a huge vibration, so it is going to be absorbed that. So yeah, that have good damping characteristics is the best answer. And yeah, D for Delhi is the right answer. Good thing is that time everyone have given the correct answer. Well, so 10, D for Delhi is the right answer. That is the next question on your screen. And sometimes it is also going to ask, what is the by which material bed of the lathe bed is going to be made? It will be the cast iron. In another form they can ask the question like that also. Okay, this is the next question. The fatigue life of a part can be improved by polishing, coating, short pinning, or electroplating? What will be answer? Fatigue life you have to be improved. What will be answer of that question, my dear friends? Everyone tell me the answer. Polishing, coating, short pinning, and electroplating. Yes, good. Every one of you have given the right answer. The correct answer is short pinning. Fine. C for Chennai is the right answer. But do one thing, my dear friends. I am going to remove that option now. Let's assume option C is not there. Now, if option C is not there, then what will be answer? If option C is not there, short pinning is not there, then what could be answer? Anybody? What you expect? Yes. Yes, my dear friends, we can say the polishing, right? By doing the polish of the surface, fatigue life you can improve. So if short pinning is not there, you can go through the polishing, right? But if in the both the option, so obviously short pinning will be the better answer, and you have to be go through the short pinning. Otherwise, polishing also going to increase the fatigue life, right? Because if you do the polishing, so what is happening? Roughness decreases, right? Now, if roughness decreases, fatigue life will be what? Increases. Right. So my meanwhile, C for Chennai is the right answer. Otherwise, A will be also right if option C is not present there. Well, that is the next question on your screen, my dear friends. Okay, now tell me one more thing I want to ask about the fatigue load. Suppose this is the one of the object having length 3 meter and this is another object having length 4 meter. Now tell me which one have more life in case of fatigue? Having same surface finish, right? Having same surface finish, I am going to assume. So now tell me which one body have more life in case of fatigue? 3 meter body or 4 meter? Answer everyone. What could be answer in that case? If you have remembered in the classroom, I have clearly told you by reducing the size of object, what happening? Their fatigue life is what? Increasing, right? So by reducing the size of the length of the, or you can say the length, by reducing the length, the fatigue life is also increases. In that case, we can say 3 meter material have better life, fatigue life compared to 4 meter. And what is the cause behind that? What is the cause behind that? Anybody can tell me? इसके पीछे क्या वजह है? 3 मीटर 4 मीटर से ज्यादा फटीग लाइफ क्यों है? कोई मुझे बताओगे? Why it is happening? Reducing length, increasing strain energy. What about others? Tell me the answer of that. Okay. Meanwhile, I am coming to the next question. This is the next question. When the temperature of a solid metal increases, what will happening? Option A, strength of the metal decreases but ductility increases. Option B, both strength and ductility of the metal decreases. Option C, both strength and ductility of the metal increases. Option D, strength of the metal increases but ductility decreases. What will be answer, my dear friends? Answer everyone. Question number 12. Write down the question number, then answer. Question number 12 on your screen. A for apple, right? Most of the answer I am going to be see here. A for apple. Okay. और किसी को कुछ लग रहा है? Strength of metal decreases but ductility is what? Increases, right? And that's why I used to say, na, my dear friends, if you talk about metal forming operation, so metal forming, what you are going to do? Before that, you are going to be heat the object, right? The object को क्या करते हो? Heat करते हो. Why you are going to heat that? So that their ductility will what? Increases. So yeah, A for apple is the right answer. The strength of the metal decreases but ductility is increases is the right answer. Okay. So A for apple is the right, and yeah, most of you have given. And that's why in the metal forming you are going to heat, and after that you are going to change their shape or size. That is the next question. On the loading of a ductile material in excess of certain value, gradual increase in elongation occur with time. Such phenomena is known as creep, fatigue, stress concentration, or none of the above. What will be? Question number 13 on your screen. Question number 13. Yes. What was the keyword? Here you can see on loading of ductile material excess of a certain value, gradually increase elongation occur with time. So that is with time it is going to be increased. Even load is constant. Such phenomena is known as what? Creep. Well, again you have given the right. Material exhibiting time bounded behavior are known as viscoelastic, inelastic, isentropic or resilience? Actually option D is resilience. What will be answer? You know, time dependent behavior. This is time bonded or time dependent behavior. What this type of material is called? Question number 14. So people who is going to give the answer C for Chennai, I am going to give one lifeline. Chennai is the wrong answer. Isentropic is wrong answer यार. हाँ, isentropic किसको बोलते हो? नहीं बोलते मटेरियल होमोजीनियस एंड आइसेंट्रोपिक, मतलब प्रॉपर्टी जो है मटेरियल का टाइम डायरेक्शन और पॉइंट के साथ चेंज ना करता हो, मतलब हर जगह सेम हो. बट हियर इट इज टॉकिंग अबाउट टाइम बाउंडेड बिहेवियर. दिस इज कॉल्ड viscoelastic material. What? Viscoelastic material. Always keep in mind this is called viscoelastic. एग्जांपल से समझो, मतलब ये दोनों इट इज ट्रीटेड लाइक अ लिक्विड एंड सॉलिड, दोनों का मिला मिला से उसके पास प्रॉपर्टी होता है. लाइक यू माइट हैव च्युइंगम. च्युइंगम देखियो, च्युइंगम तो खाया होगा आपने. च्युइंगम कैसा मटेरियल की एग्जांपल है? दैट विल बी एग्जांपल ऑफ विस्कोइलास्टिक, है ना. लोड लगाओ, कुछ टाइम लगातार हो रहा है, फिर छोड़ दोगे, धीरे धीरे होगा. मतलब विस्कोइलास्टिक ये भी है कि वंस आई एम गोइंग टू बी, जैसे हमारे पास बॉडी है, राइट, हमने लोड लगाया, इसमें डिफॉर्मेशन हो गया, राइट, एंड वंस आई रिमूव द लोड, तो ये बहुत धीरे धीरे अपना शेप को गेन करेगा टाइम के साथ. So that type of material comes under the category of viscoelastic, right? Yeah. So keep in mind this is called viscoelastic material and it is going to be asked. और यहाँ पे मैं आपके लिए लिख भी दिया हूँ, देखो यहाँ पे मैं everything is written here. Property of material that exhibit both viscous and elastic characteristics when undergoes deformation. Viscous material like water resist shear flow and strain linearly with the time when stress is applied. Material that shows both elastic and viscous behavior when it is deformed. As I told you, you can think about the chewing gum. So this comes under the category of that. So try to remember that point, my dear friends. Time dependent, right? So that is the next question. To improve the machinability, the alloying element to a steel is cobalt, vanadium, sulfur, or manganese. You have to be increase the machinability, right? So which material you have to be used? Answer everyone, my dear friends. Question number 15 on your screen. Yeah, sulfur. Okay, I am going to be see here. There is a, ये क्या हो गया? बंद हो गया सब. am audible ना? Visible? am I visible? Just okay, no, just give 1 minute, my dear friends. Just 1 minute. हाँ, मुझे मेरा मोबाइल नहीं दिख रहा है सर. हाँ, अब दिख रहा है. Okay, just 1 minute, my dear friends. हाँ, not visible ना? Everything is fine. Yeah. See, my dear friends, here I think some of you are going to with option C, someone with option D. देखो, if you are going to add the sulfur, है ना, little bit they are going to increase the machinability. But if you are going to increase the manganese ना, ये बहुत ज्यादा machinability की improve कर देगा. Yes, I am telling you, sulfur, even sulfur little bit can increase the machinability, right? But here, if the manganese is in the option, you have to be go through the manganese. Okay, so keep in mind, my defense, manganese. What the cobalt and vanadium is going to be do? So okay, one more thing. See here, machinability M, manganese is M. So keep in mind, machinability improving manganese, right? M for machinability, M for manganese. So that's why you could be able to remember it thing. Okay, so keep in mind. If okay, suppose in the option D is not there, then sulfur will be the right answer. Suppose option D is not there, then you can go through with the sulfur, right? Well, so 15 you have given the correct answer. Here, my dear friends, everything I have written, you can see here, vanadium, everything I have written, I will share that PDF, right? What is the purpose? To alloy the element. Sulfur, here you can say little bit improve the machinability. This is the next question. Work hardening in a ductile material increases its ductility, plasticity, electrical conductivity or strength. Work hardening ductile material में क्या increase करता है? What will be answer? Tell me. Work hardening in ductile material increases ductility, plasticity, electrical conductivity, or strength. Everyone answer. Question number 16 on your screen. Work hardening. Listen, my dear friends. Whenever you talk about work hardening, na, we can understand that it is a hot working or cold working. Always keep in mind it is a cold working, right? And cold working always reduce the ductility. Whenever you talk about work hardening, ना, तो जो मैं आपको पढ़ाया था मटेरियल याद होगा जब प्रोडक्शन की हम बात कर रहे थे. So work hardening basically cold working, and cold working what? It not going to be increase ductility, right? So simply we can see it is going to increase what? Strength. So D for Delhi is the right answer. Okay. Right. कुछ खा रहा हूँ. Okay. Someone is asking, sir, what is cold working or what is work hardening? See, my dear friends, work hardening, also known as strain hardening, is a process of plastically deform a ductile material below its recrystallization temperature. That means it is a cold working. This is also known as work hardening. Right. So keep in mind that thing. Okay, everything I have written there. Just go through and read all that point. Which of the following structure of steel is magnetic in nature? Which one of the structure is magnetic in the nature? Delta iron, alpha iron, and I think this is given gamma iron, right? Or option D is none of the above. What will be answer? Thank you. Thank you, my dear friends. You guys are excellent. Right. चलो बताओ क्या हो जाएगा इसका आंसर. स्टील इज मैग्नेटिक इन द नेचर, माय डियर फ्रेंड्स. राइट. सी अभी मैं बात करूंगा फेरोमैग्नेटिक टेम्परेचर का. राइट. फेरोमैग्नेटिक टेम्परेचर जो कि कितना होता है? एनीवन हैव रिमेंबर फेरोमैग्नेटिक टेम्परेचर फॉर स्टील फॉर डिफरेंट मटेरियल? फेरोमैग्नेटिक that you have to say temperature, Curie temperature could be different, but here at the room temperature generally what alpha iron is going to exist, and it is magnetic in the nature. So always keep in mind C for Chennai. And what is Curie temperature? Anyone have remember Curie temperature? 726, 768. Yeah, 768, 769, 770. Whatever is there, it is close to 770. Okay, in the option whatever is close to that you can go through. So this is called Curie temperature. इससे जब नीचा होता है ना तो हमेशा आयरन जो होगा ना आपका स्टील हमेशा जो है हमेशा मैग्नेटिक होगा. That will be always magnetic. So alpha iron exist at the room temperature, so it will be magnetic. But once you heat beyond that, then that magnetic property vanishes, right? So if you talk about delta iron, you talk about the gamma iron, that all are non-magnetic in the nature, right? Well, good. So remember all that point, my dear friends. Here I have written all the things. Okay, alpha iron has BCC, body centered. Okay, here I have given 769. Can you tell me what is in the Fahrenheit temperature? One exam I haven't remembered, that is while India, I think. While India, in that question was that what is the Curie temperature, and option was not in the degree Celsius, it was in the Fahrenheit. ठीक है, तो थोड़ा मुझे बता Fahrenheit में क्या होगा. Actually student is just going to remember sir this is 769 770 degrees Celsius, but option was in the Fahrenheit. So right, try to remember that thing also. Well, that is the next question. Which portion of the creep curve provide the information on steady state creep rate? Primary stage, secondary, tertiary, or all of the above? What will be answer, my defense? Answer everyone. दोनों चलेगा. कौन है हिंदी वाले? Both will go. Bilingual will be there. Don't worry. Right. Question number 18 on your screen. देखो, if you go through creep curve ना, my dear friends, there are 3 zones: primary zone, secondary zone, and tertiary zone. ठीक है. In the Cribb curve, if you go through, you will find 3 zones: primary, secondary, and tertiary. 3 zones. So the question is that which zone talk about the information gives about the STD state. STD state. So my dear friends, see that curve. See, this is see man. This is called primary Cribb. This is called secondary Cribb. This is called tertiary Cribb. Now see the diagram and tell me कहाँ पे आपको changes कम नजर आ रहा है. STD means what? The changes is not going to much more, right? That is the simple meaning of STD ना. So मुझे बताओ कहाँ पे आपको दिख रहा है प्राइमरी, सेकेंडरी और टर्सरी. In which zone you are finding STD? Everyone tell me. Yes, my dear friends, always keep in mind that will be the secondary Cribb. That will be the secondary zone or secondary Cribb. Okay. Tertiary, increasing Cribb strain rate. They may ask in which zone Cribb strain rate is going to be increased. So it will be the tertiary. So meanwhile, keep in mind the answer will be the B for Bombay. And what you have given the answer? Secondary stage is the right answer. And yeah, most of you are, I am going to be give the right answer. Good. Well, so question number 19 on your screen. Steel is mainly responsible for the occurrence of hairline crack. In steel, mainly responsible for the occurrence of hairline crack: sulfur, hydrogen, nitrogen, or manganese. What will be answer? What will be answer? What do you think? देखो दोस्त, मैंने आपको क्लास में क्लियरली बोला था कि हाइड्रोजन कहीं पर भी होगा ना, हाइड्रोजन गैस कहीं पे भी ट्रैप होगा, एनी टाइम इफ हाइड्रोजन गैस इज ट्रैप, it will give a hairline crack, hairline, because it is a very light. So always keep in mind that type of crack you are going to find, that is mainly because of hydrogen, not because of sulfur, nitrogen and manganese. Because because क्योंकि आपको पता है ये जो हाइड्रोजन है ना बहुत लाइट होता है और जब ये निकलेगा so it is going to make a hairline crack. So will be the hydrogen is the right answer. B for Bombay, 19 B for Bombay is the right answer. And keep in mind all that point, my dear friends. That question is going to ask in your exam. This is the next question. Fully recoverable but time dependent deformation is known as elastic deformation, inelastic deformation, viscoelastic deformation, plastic deformation. What will be answer? Question number 20 on your screen. Just now you have seen, just now we have discussed about the time dependent deformation, something like that. Now, just now you have seen earlier to the 5 or 6 question. So what will be answer of that question, everyone? Yes. Keep in mind that point. Okay, one thing ना, कभी भी जब तुम time dependent वाला बात देखो ना, forget all the things, go through the viscoelastic. Whenever you find the keyword na, time dependent deformation like that, in whole material science, answer will be only one thing. This is viscoelastic deformation, right? So always keep in mind the answer will be viscoelastic and keyword is time dependent, right? Okay. So that thing you have to be keep in mind. That is the next question. What was the question? Okay, come on that question. With increase in percentage of carbon in the steel, which of the following property does not increases? With increase in percentage of carbon in the steel, which one of the following property does not increase? This thing is going to be asked. What will be answer? Tell me. With the increase in percentage of carbon in the steel, which of the following property does not increases? Modulus of elasticity, ductility, toughness, or hardness? What increases it is going to be asked, my dear friends. Listen, my dear friends. Ductility decreasing. Just keep in mind one thing. अभी दिमाग में बैठा लो दिमाग में one thing. Whenever you are going to increase the percentage of carbon, ductility always decreases, baba. That's why mild steel is more ductile compared to high carbon steel. Because in the high carbon steel, percentage of carbon is high. अब खुद ही सोचो, my dear friends. I am telling you the cause. See, this is the atoms of, right? This is the atoms of what, my dear friends? Let's assume you are talking about this is the carbon. This is the, you can say, steel, right? And always keep in mind, carbon is going to be take at the interstitial site. यहाँ पे carbon आएगा, यहाँ पे. Always, sometimes this is also going to ask, which position carbon is going to occupy. So it is going to be at the interstitial site. Now tell me, my dear friends, one thing, everyone. This is the like that, and here the carbon atom, here is no carbon atom. Now tell me, in which case more interatomic force will be, in case of 1 or in case of 2? In which case more interatomic force we can observe, in case 1 or in case 2? Yes my dear friends, in case 2, because sir यहाँ पे जो interatomic force होगा ये ज्यादा stronger होगा compared to that. यहाँ भी interatomic forces है, but that is lesser. So my dear friends, by adding the percentage of carbon, they are going to occupy at the interstitial site, and once they will come at the interstitial site, now tell me, is it difficult to change their length or easy? Obviously when it was like that, it was easy because interatomic force is less, but once carbon came at the interstitial site, the interatomic force becomes stronger. So in that case length change will be less, so ductility decreases. Always keep in mind, क्योंकि ये इंटरेस्टियल साइट पे आ गया है, और इसको इंटरेस्टियल साइट पे आने के कारण इंटर एटॉमिक फोर्स बढ़ गया, इसीलिए ज्यादा ये डिफॉर्म नहीं होगा, बट यहाँ पे ऐसा नहीं है. सो व्हाट यू कैन से, बाय इंक्रीजिंग इन द परसेंटेज ऑफ कार्बन डक्टिलिटी डिक्रीजेज. Ductility always decreases, not increases. Now take me, what about hardness, Babu? What about hardness? What is hardness? Hardness is basically resistance against the penetration, resistance against the scratch, right? Scratch. Now tell me, जब यहाँ पे नहीं था, सुनो, जब ये यहाँ पे नहीं था, पुराने वाले मोबाइल में करता हूँ, गिर जाएगा तो कोई दिक्कत नहीं, तो स्क्रैच करना आसान था, इट वाज इजी टू स्क्रैच, बट वंस कार्बन केम ना, तो स्क्रैच करना मुश्किल हो जाएगा. क्यों? बिकॉज इंटर एटॉमिक फोर्स बिकम्स स्ट्रॉन्गर. सो बाय एडिंग द कार्बन it will be difficult to scratch over the surface, so hardness increases, baba. So always keep in mind, by increasing percentage of carbon, hardness increases. Hardness is resistance against the penetration, against the scratch. Once it will come, they will resist more. Clear to everyone? So we can say, sir, hardness will be what? It will be okay, increases. Hardness will be increases. Okay, so D for Delhi is the right answer. Go through the basics. Usually I used to say in the class, mechanical engineering is not for, रटने के लिए है ही नहीं. That is for all about understanding, and you guys just start by hurting the things. So यहाँ पे देखो, as you are going to increase the percentage of carbon, strength increases, resilience, surface hardness, that all thing is going to be. Here we can say modulus of toughness decreases, ductility decreases, malleability decreases, formality, all these things decreases. So please remember that PDF. It will be very, very helpful, right? It will be very, very helpful. D for Delhi is the right answer. Okay, come to the next question. That is the next question on your screen. Which one of the following material is closest to diamond in the hardness? देखो, सबसे ज्यादा हार्ड मटेरियल क्या है? Obviously it is diamond. Obviously it is diamond ना. But the question is that close to diamond. Aluminum oxide, carbon dioxide, cubic barium nitride, or silicon dioxide. What will be answer of that question? तुम लोग लाल कर देते हो दिल दे देके. And yeah, don't forget to like the session, right? Yes, my dear friends, second hardness जो यहाँ पे हो जाएगा, that will be cubic barium nitride, CBN. CBN. It is working like a what? ये किसके तरह काम करता है? If you have remember, I have told very clearly in the class, abrasive material. It work like a what? Abrasive material, है ना? ये जो है abrasive material की तरह काम करता है. So keep in mind, aluminum, you can say cubic barium nitride. Chalo, fine. Everyone have given the right answer of that question. What was the question number? It was, well, question you have given. Now that is the next question on your screen. Okay, that is from the testing of materials, right? Okay, I think this is, can I zoom out it? Is it visible? Tell me. Is it visible if I am going to zoom out? Visible? Tell me. Is it visible? Is it visible? ये visible है, बताओ मुझे पहले. Visible? Only that question? Not. Okay, try to answer that question if you can. You have 1 minute of time, my dear friends. 23rd, question number 23rd on your screen. Question number 23rd on your screen. So I am getting here Chennai, Chennai, Chennai. What about others? Bombay. Okay, Bombay, Chennai, both is coming. So most correct answer is what, my dear friends? C for Chennai is the right answer. Okay, C for Chennai is the right answer. Okay, now I'm going to zoom it. Chennai. Okay, Chennai. देखो, A, ductility is going to find by the tension, tension test. Always this keep in mind. Tension test is going to be calculate for the ductility of the material. After that, you talk about B, endurance limit. You are going to talk about the fatigue life. So it is going to match with B. If you talk about toughness, so toughness is going to through what, my dear friends? Impact test. Just now you have seen the question. Impact load था तो कौन सा energy होगा? Toughness. So toughness you are going to be checked by the impact test. Next is what? Resistance to penetration. Just now I have talked. It is what? Hardness. Na? Hardness. So resistance to penetration means you are going to be talk about the hardness. So go through the option, you will find the answer. So it is an easy question. Not easy. You have to remember all that. Now I am coming different types of question. This, the principle of superposition is valid for any elastic material, all metals, linear elastic material, homogeneous. Principle of superposition. What do you mean by superposition, my dear friends? What do you mean by the term superposition? सुपरपोजिशन से क्या समझते हो? Answer that question first. Any elastic material, all metal, linear elastic material or homogeneous material? Tell me. सुपरपोजिशन ना, तो देखो सुपरपोजिशन मींस एक दूसरे को ऐड कर सकते हैं हम सिंपली. सो एनी इलास्टिक नोट दैट मस्ट बी लीनियर. Anything in the linear, you can go through the superposition concept. So question will be the linear elastic. Any elastic material note, the material which is linear elastic, that can show the superposition principle, not any elastic. Sometimes I have seen in the classroom a student going through the option A, they think are elastic material, but this is only valid when the linear elastic is there. So always keep in mind C for Chennai, not A for apple. Any elastic is not necessary, right? It should be linear elastic, then you can apply the superposition. That is easy question. What do you mean by allotropic of material? An allotropic material. What do you mean by allotropic? Allotropic is what, my dear friends? Allotropic. What do you mean by allotropic? Allotropic means this is that types of material which can exist in different crystal structures at different temperatures. मतलब अलग अलग टेम्परेचर पे जब ये अलग अलग स्ट्रक्चर शो करेगा, then it is called allotropy. Means at a different temperature they shows different crystal structures, right? Some temperature they can see BCC, at some temperature they can show the FCC, hexagonal, अलग अलग स्ट्रक्चर शो करेगा, उसको मैं allotropy बोलता हूँ. So atoms distributed in random pattern, atoms distributed in fixed pattern, different crystal structures at a different temperature. So C for Chennai is the right answer, and it was a very easy question. I think everyone can answer that question, right? Any material which shows different crystal structures at different temperatures is called allotropy, right? Or allotropic material. So keep in mind, very easy it is. So tell me, if you talk about a steel, it is allotropic or not, my dear friends? Yes, sir, it is allotropic because that shows different structures at different temperatures. Yeah. Pudding is the process employed for converting iron ore into pig iron into wrought iron, pig iron into cast iron, none of the above. What will be answer of that question on your screen? Question number 26 on your screen, my dear friends. Question number 26 on your screen. Question number 26 on your screen. So that time A, B, C, D सारा ऑप्शन आ रहा है ना? That time I am getting all the option A, B, C, D, E, F, G, H. दे दो, नहीं है फिर भी दे दो भाई, हमारा मन है हम कुछ दे दें सर, सही है. 28 I am going to give the lifeline. A for apple is the wrong answer. This is a lifeline for you. Okay, C for Chennai is the wrong answer. D for Delhi is the wrong answer. My dear friends, pudding is a process in which pig iron is going to be converted in the wrought iron. You know which is the pig iron is the impurest form of iron. impurest form जो होता है ये आपका pig iron होता है, और जो purest form होता है that is the wrought iron. So pudding is a process in which impurest form of iron is going to be converted in the pure form of iron, and that process is called is what? Puddings. So हमेशा याद रखना पुडिंग से हम क्या करते हैं, पिग आयरन से रॉट आयरन बनाते हैं. कैसे? बाय रिड्यूसिंग द परसेंटेज ऑफ कार्बन. कार्बन को कम करके बनाते हैं, राइट कार्बन को कम करके हम बनाते हैं. पिग आयरन यू नो देयर इज नो प्रैक्टिकल एप्लीकेशन दे हैव. someone is going why pig iron they not have any practical application because it is a very very brittle, right? Huge amount of carbon is there, so keep in mind that is coming here. Okay, now my dear friend, just one thing I want to be tell you. Let's assume in the same question option B is not there. Let's assume option B is not there, then what will be answer? Let's assume option B is not there, then what will be the answer of that question? Option B is not there, let's assume, then what could be the answer? Okay, option D is also no baba, then pig iron into cast you can assume. हालांकि that is the mostly pig into the wrought iron, but yeah, since I am going to be reducing the percentage of carbon, see in one mid time बीच में हमें cast iron भी मिलेगा, ठीक है ना, बीच में हमें cast iron भी मिलेगा, तो मैं C के साथ जा सकता था. कब? जब हमारे पास ऑप्शन बी नहीं हो. एंड दैट्स व्हाई आई एम टेलिंग यू ना, यू हैव टू बी फाइंड द मोस्ट एक्यूरेट आंसर ऑन द गिवन एमसीक्यू. और ये आपको एग्जाम में खुद सोचना पड़ेगा, बिकॉज इफ यू बेसिक इज नॉट क्लियर यू कैन नॉट बी एबल टू सॉल्व दैट टाइप ऑफ क्वेश्चन. बिकॉज यू नो पिग आयरन से जब मैं रॉट आयरन जाऊंगा तो बीच में तो कास्ट आयरन बनेगा, राइट? सो देन यू कैन गो थ्रू चेन्नई. मीनवाइल यू हैव टू बी गो थ्रू बी फॉर मुंबई, राइट माय डियर फ्रेंड्स? टेल मी. Yeah, so that is the next question on the screen. Compressive test performed on the cast iron will have fracture occurring. No. Meanwhile, you have to answer. कौन है ये? रोशन, जो भी है, शर्मा जी, रॉय शर्मा. पहले तो आंसर दो, बाद में कोर्ट जाओगे, है ना? फर्स्ट गिव द आंसर, तभी तो जाओगे कुछ आंसर लगा के. What will be answer? Question number 27 on your screen. Question number 29 on 27 on your screen. Compressive test performed on a cast iron. My dear friends, if you have remember cast iron, and in the theory of strength of material, I have told you कि maximum shear stress occur at a 45 degree of the plane. Have you remember or not, my dear friends? You have forget. अभी तो याद रखो यार, एग्जाम के बाद भूल जाना. अभी तो कम से कम याद रख लो, एग्जाम के बाद तो वैसे भी याद नहीं करना है आपको. But till now, try to remember यार. In the strength of material, I have taught you about that, right? This कुछ ऐसा करके है ना. So this is something like that. And one plane which is at angle 45 degree. एक हमारे पास plane है, right? This is the plane which is at angle of what, my dear friends? 45 degree, है ना? So this is called maximum shear stress plane. This is called what, my dear friends? Maximum shear stress plane which is occurring at angle of 45 degree, or this is called oblique plane also at a 45 degree. So जब कभी भी ये टूटेगा, especially if you talk about cast iron, it is weak in shear. It is weak in shear. So if they are going to fail, तो यहाँ से fail होगा, ऐसे fail होगा, ऐसे, ठीक है? So we can say along an oblique plane. A for apple is the right answer. Perpendicular to the axis of load. How we can say along the axis plane it is going to be fail. So A for apple is the right answer. Right? Sarma ji, clear है बात? Along the axis of load, no. Perpendicular to the axis of load, no. None of the above. Here load I am going to be applied. Perpendicular, that plane is there. So along, keep in mind, whenever you talk about brittle material, Baba, whenever you talk about brittle material like cast iron, they are weak in the shear. And I know, especially if you talk about unidirectional load, maximum shear stress occur at a 45 degree plane, which is called 45 degree oblique plane, and it will fail along that. So correct answer is what? A for apple, not C for Chennai, Delhi, and all of that. Right? So 27, A for apple is the right answer. Come to the next question. Okay, question number 28 on your screen. In tensile test of mild steel, necking will start. You are going to take the tensile test. mild steel का कर रहे हैं तो कहाँ पे necking start होगा? at lower yield stress, at upper yield stress, at ultimate tensile stress, just before the fracture. Just before the fracture. Question number 28 on your screen. And this time आप लोग लाइक करने में कंजूसी कर रहे हो, मजा नहीं आ रहा है, right? Yes. So my dear friends, I am going to give one lifeline. D for Delhi is the wrong answer. Now tell me the answer. D for Delhi is the wrong answer, Baba. At the lower yield, at the upper yield, yield is not. Necking always takes place at the ultimate tensile stress. Necking मतलब पतला होना बाबा, मेरे देशवासियों, ये लो बॉडी है, हम टेंसाइल टेस्ट कर रहे हैं, है ना, तो पतला होगा नेकिंग. इफ यू आर गोइंग टू बिलीव, समटाइम्स कुछ ऐसे होगा बनेगा, बहुत लोड लगाओ, है ना, बहुत लोड लगाने के बाद इस तरह से बन जाए. इफ द लोड इज you are going to increase more than the ultimate stress, then it will be happening something like that, and this is called necking. And necking you can find at the ultimate tensile stress or beyond that. So C for Chennai is the right answer, not A for Apple, not B for Bombay, not C for Chennai, just before the fracture. After that it will get fracture. After ultimate tensile stress they will get the knocking, you can say the what, necking होगा. Further you are going to increase the load, तब ये fracture हो जाएगा. क्लियर है बात की नहीं है? तो बी क्लियर, डोंट मेक अ मिस्टेक लाइक दैट. ओके, नाउ टेल मी माय डियर फ्रेंड्स, वन थिंग आई यूज्ड टू आस्क इन द क्लासरूम. जब हम टेंशन टेस्ट करते हैं तो यील्ड स्ट्रेंथ जो आपको आता है टेंशन टेस्ट में, व्हिच इज यील्ड स्ट्रेंथ यू आर गेटिंग, लोअर यील्ड और अपर यील्ड? अरे टेंशन टेस्ट करते हो ना, स्पेशली वी टॉक अबाउट माइल्ड स्टील, सो इट इज कमिंग. सो दिस इज कॉल्ड अपर यील्ड पॉइंट, this is called lower yield point. Now tell me, in the tensile test, which point you are getting, upper yield or lower yield? They may ask also. Yes my dear friends, always keep in mind this is lower yield. Why? Because upper in the sharp, it is like that sharp, and I didn't, मुझे पता ही नहीं चलता है कि भाई ये कब आया, मुझे पता तब चलता है जब ये आता है. तो just for knowledge keep in mind, हमें कभी भी yield point दिया हो ना, that means you are going to be talk about the lower yield, not upper yield. कभी भी yield point दिया हो, always you are going to talk about lower yield. चलो गुड, मजा आ गया, अच्छा है, आप लोग को समझ में आ रहा है, गुड. कम टू द नेक्स्ट क्वेश्चन. चलो, that is the next question. When mild steel is subjected to tensile loading, the fracture will be star shape, flat shape, cup and cone. Very frequently it is going to be asked granular shape. I think everyone can answer that question. Question number 29, everyone can answer. Okay, let me, yeah, that time expected. इस बार मुझे पता था सब सही दोगे. है ना. So this is called cup and cone fracture, right? Cup and cone fracture. So see for no, कभी क्लास में मिलो, I will tell why it will be cup and cone, है ना, why it will be cup and cone. ठीक है, चलो अभी नहीं, बाद में बता दूंगा, रहने दो. बस just not try to remember it will be cup and cone, but why I will tell you in some another session, because अभी अपने को ऑलरेडी 3 घंटा का शेड्यूल है हमारा, तो बहुत लंबा हो जाएगा आपका. This is the next question. इंडेंटर यूज्ड इन ब्रिनल हार्डनेस टेस्ट इज, इंडेंटर जो हम लोग ब्रिनल हार्डनेस टेस्ट, यू आर गोइंग टू टेक द हार्डनेस, तो इसमें इंडेंटर जो यूज करते हैं उसका शेप क्या होता है? दैट इज द क्वेश्चन नंबर 30 ऑन योर स्क्रीन. क्वेश्चन नंबर 30 ऑन योर स्क्रीन, व्हाट विल बी देयर? शेप. यस यस, हाँ ठीक है. और इंडेंटर यूज्ड इन ब्रिनल हार्डनेस टेस्ट, दिस इज कॉल्ड फर्स्ट डिस्ट्रक्टिव और एनडीटी. माय डियर फ्रेंड्स, basically two types of testing of material. One is called destructive testing, another one is called non-destructive testing, right? Destructive and non-destructive. Destructive testing का मतलब है मैंने इसको जांच कर लिया, उसके बाद ये जो सिंपल है, सैंपल है, या जिस पे मैंने जांच किया वो यूज के लायक नहीं हो, बर्बाद हो चुका है. दैट इज द मीनिंग ऑफ destructive testing. एनडीटी का मतलब है हमने टेस्ट तो किया, हमें जो प्रॉपर्टी पता करना था पता कर लिया, बट आफ्टर दैट मटेरियल कैन बी यूज. इसका मतलब है ये नॉन डीटी है, एनडीटी है, नॉन डिस्ट्रक्टिव टेस्टिंग है. तो यहाँ पे जो क्वेश्चन पूछा जा रहा है ब्रिनल हार्डनेस, ये जो है हमेशा ये डिस्ट्रक्टिव टेस्टिंग है, डीटी है. सो इंडेंटर यूज्ड, ये जो होता है बाबू स्क्वायर बेस पिरामिड, यहाँ पे नहीं होता, पिरामिड रॉकवेल में होता है, पिरामिड हैपनिंग इन द रॉकवेल, नॉट हियर. सो डोंट, ए फॉर एप्पल इज नॉट द राइट आंसर. ओके, नॉट स्क्वायर शेप स्टील टंगस्टन कार्बाइड, सी फॉर चेन्नई इज द राइट आंसर. हमेशा याद रखो ये सारी चीजें, आता है छोटी छोटी बात है, mostly they are going to be asked, so try to remember. C for Chennai is the right answer. Pyramid होता है but that is in the Rockwell, I will take that. I will ऐसा भी क्वेश्चन मैं लाया हूं आपके लिए. But meanwhile इन केस ऑफ Brinell hardness, sphere made of steel और tungsten, sphere के शेप में होता है यार. I have come with the diagram also. ये कुछ इस तरह से होगा. Have you did that test in your college? कॉलेज में किए हो ये टेस्ट? हाँ सर, लाइव में तो हम लोग भाग जाते थे. जब लाइव का घंटी होता था, लेक्चर होता था, तो हमारा भागने का घंटी होता था, है ना. कौन करता है सर? इसलिए नहीं पता है आपको. So it is something like that, right? And you know, my dear friends, hardness, Brinell hardness number. This formula also try to remember. Remember, okay? This formula remember. They may ask sometimes 2p pi d upon d minus d square minus d square. So that is also going to be asked, right? कॉलेज होता ही नहीं था, हम तो कोरोना वाले इंजीनियर हैं. ओके, गुड, नो प्रॉब्लम. आंसर दैट क्वेश्चन जस्ट नाउ आई हैव टोल्ड, ट्राई टू रिमेंबर. मुझे पूरा भरोसा है किसी को याद नहीं होगा. मुझे पूरा पता है, नो वन हैव रिमेंबर. जस्ट नाउ आई हैव टोल्ड ना रिमेंबर. किसी को याद नहीं. बताओ व्हाट विल बी आंसर ऑफ दैट क्वेश्चन? आंसर एवरीवन. क्वेश्चन नंबर 31st ऑन योर स्क्रीन. Question number 31st on your screen. So Chandni, okay, Chandni, good. What about others? Ravan, Ravan, you are Nitish. अलग अलग नाम है. ओके, या चलो देखो आने लगा ना. अभी मैं बोला था, अभी मैंने बोला याद रखो, बट या बिकॉज यू गाइज आर रियल गजनी, नो नीड ऑफ एनी एक्टर फॉर दैट. ए फॉर एप्पल इज द रॉन्ग आंसर. जस्ट नो. अच्छा बोलोगे सर ऊपर में यहाँ पे 2 था सर, यहाँ पे नीचे में कर दिया, इसलिए मेरे को कंफ्यूजन हो रहा है. यार ग्रेट स्टूडेंट हो. ऊपर में यहाँ पे 2p था, यहाँ पे आपने 2 कर दिया, कोई फर्क नहीं पड़ता. व्हाई यू आर गेटिंग कंफ्यूज इन दैट? इजीली यू कुड बी एबल टू डू दैट ना. हाँ, ऑलवेज कीप इन माइंड. ये याद रख लो यार, इसको याद कर लो, जैसे भी याद करो, मुझे नहीं पता बट याद करो इसे, राइट. Brinell hardness number BHN. That is the next question. Okay, now you are able to answer that question. The measure of Rockwell hardness test: depth of penetration of indenter, surface area, height of rebound, projected area of indentation. What will be answer of that question? Question number 31st, 32nd on your screen. Question number 32 on your screen. Depth of penetration of indenter. Rockwell hardness test is basically going to talk about the depth of penetration of indenter A for apple. My dear friends, you know one thing. You just one thing I want to tell here. Hardness basically two types. Listen, hardness basically two types, Baba. Hardness basically two types. How, sir? Just now I have given one diagram, one concept. Hardness is what? Sir, it is the resistance against the scratch और अगेंस्ट द पेनिट्रेशन. टू ही थिंग ना, या तो ये स्क्रैच को रेसिस्ट करेगा या नहीं तो पेनिट्रेशन मतलब होल करने को रेसिस्ट करेगा. सो माय डियर फ्रेंड्स, समटाइम्स इट इज गोइंग टू बी आस्क्ड कि रॉकवेल हार्डनेस टेस्ट इज व्हिच टाइप ऑफ हार्डनेस टेस्ट, सरफेस और यू नो व्हाट यू कैन से इंडेंटेशन. सो इट टॉक अबाउट द बाबा इंडेंटेशन. ये इंडेंटेशन के बारे में बात करता है, सरफेस स्क्रैच की बात नहीं करता है. बात समझ में आ रही है? So measure of Rockwell test is the depth of penetration of indentator. The meaning is that it talk about the, not about the screen. It talk about the penetration और indentation hardness. Clear है बात? तो दो तरह का हार्डनेस होगा बाबा, एक सरफेस रफनेस और एक इंडेंटेटर. तो जितना भी तुम देख रहे हो, रॉकवेल हो गया, इसके बाद ब्रिनल हो गया, that all talk about the indentation, not the surface. Okay, keep in mind that question is also going to be asked. Okay, good. Come to the next question. The Rockwell test of hardness employ. Okay, that time you could be able to answer. Okay, steel, diamond, steel. What will be answer? Pyramid will be answer. But what pyramid? Steel, diamond. किसका pyramid बनेगा बताओ? Question number 33. Okay, Rockwell test hardness. Okay. This is not a pyramid. Here it will be cone. It will be cone, my dear friends. Okay, not pyramid. A Rockwell test hardness employ basically diamond cone I am going to be used here. The correct answer is what? B4, Bombay diamond cone, not pyramid. Okay, some another question is there in which pyramid will be used. Don't worry. The CharP test is conducted to measure. What is the purpose of CharP test? What is the purpose of CharP test? Just now you have seen creep strength, toughness, fatigue strength, elastic strength of material. Answer everyone. Question number 34. CharP test is conducted to measure. CharP test. I think that time you guys are really going to be give the right answer. What answer? B for Bombay, D for Delhi. No, my dear friends. CharP test always going to be conduct for the check of the toughness, right? Toughness. Keep in mind at least CharP is going to measure the toughness, not the elastic strength of material, fatigue strength or creep. This is talk about the toughness, right? So keep in mind CharP for toughness. Yes, always keep in mind, my dear friends. याद रखो, कम से कम ये सब याद कर लो, है ना, काम आपका पक्का बन जाएगा, बता रहा हूँ, इससे बाहर कुछ होता ही नहीं है। जो मैं क्वेश्चन ले रहा हूं ना दोस्त, उससे बाहर कुछ होता ही नहीं है। आप देखो एक बार जाकर पीवाईक्यू सॉल्व करो, तो कम से कम याद करो ये सब। अब कम टाइम में मैं क्या कर सकता हूं आपके लिए। ओके, दैट इज द नेक्स्ट क्वेश्चन ऑन योर स्क्रीन। Which one of the following mechanical property provided by the notch bar test? Impact strength, hardness, resilience, or endurance limit? Tell me the answer of that question. Yes, notch bar test for what, my dear friends? Endurance limit नहीं बाबा, notch bar test endurance limit थोड़ी ना करते हैं। D for Delhi is the wrong answer. Okay, impact strength. Yes, notch bar test for what? Impact strength. So A for apple is the right answer. याद कर लो, अभी याद कर लो, कभी आना क्लास में मैं दिखा दूंगा कैसे, ठीक है? We'll discuss sometimes in class, don't worry. अभी याद कर लो, बट ठीक है, जो जरूरी है उतना कर लो एटलीस्ट। नेक्स्ट, fluorescent dye method of testing used for detecting of the ... of an object: surface crack, interference defect, structure characteristics, or none of these. Question number 36 on your screen. This, ये जो मैं ले रहा हूं, that is one chapter called testing of material, है ना? That is the question for testing of material. Important है दोस्त, testing of material important है, especially Brinell hardness, Rockwell hardness, है ना? Ultrasonic testing, that all is going to be asked various times. So remember, testing of material is most important topic. 35A, I am going to be get the answer. Question number what? 35. 36 now. Question number 36. Yes, surface crack. A for apple is the right answer. Surface crack is the right answer. Keep in mind. This is going to be done by the ultrasonic वगैरह से मैं इसको करता हूँ, ठीक है? इसको अल्ट्रासोनिक से करेंगे, इंटरनल डिफेक्ट, विल सी। चलो, वेल, दैट इज द नेक्स्ट क्वेश्चन ऑन स्क्रीन. प्रिंसिपल ऑफ डाई पेनिट्रेशन टेस्ट इज बेस्ड ऑन, डाई पेनिट्रेशन टेस्ट इज बेस्ड ऑन मैग्नेटिक domain, absorption of X-ray, capillary action. Next is what? Polarized sound wave in liquid. Question number 37 on your screen. Dye penetration test. What will be answer, my dear friends? Yes, C for Chennai. Good. याद रखो. Dye penetration test and C capillary action. CD. Usually I used to say CD. Dye penetration, it will related to the capillary action. Tomorrow, as I told you, my dear friends, tomorrow you have a mock session, not mock interview, mock, where I am going to take 100 question, and that will be the same as according to your exam requirement, and in that I have taken what is capillary action. So tomorrow question will see what is capillary action and how you can calculate. Meanwhile, try to remember C for Chennai is the right answer. Okay, so okay, 38 number. That is the next question. Which of the following type of rays is used in radiography for the inspection of welded joint? Which of the following type of rays is used in radiography for inspection of welded joint? X-rays, infrared, UV rays और visible rays? क्या यूज करते हो यहाँ पे? 38. What will be answer? नहीं, देवकी, whoever there. अब संभव ना, आपके पास टाइम नहीं है ना. इन BDL we can do, बट अब आपके पास टाइम नहीं है दोस्त. थोड़ा सोचो, कल मैं एक सेशन ले रहा हूं, परसों आप जर्नी में रहोगे, हाउ यू कैन डू. पता चला मैं आके यहाँ बोल रहा हूँ, अब ओर्थ नहीं है, बट यस, अगला जो होगा BDL सेशन में आई विल कम विद दैट, सो डोंट वरी. Yes, here, which of the following type of rays is used in radiography for the inspection of welded joint? That is going to use the X-rays. हमारे बॉडी में भी यार, अब एक बात बताओ, इंस्पेक्शन ऑफ वेल्डेड जॉइंट, हमारे बॉडी का भी जो बोन फ्रैक्चर होता है तो क्या यूज करते हो? एक्सरे यूज करते हो. तो वेल्डेड जॉइंट को सही देखने के लिए है कि नहीं, आई एम गोइंग टू यूज द एक्सरेज. सो एक्सरे इज द राइट आंसर. कीप इन माइंड बाय दैट वे. और कुछ तो हो ही नहीं रहा है. इंफ्रारेड का अलग काम है. इंफ्रारेड कहां पे यूज होता है? इन योर रिमोट. टीवी का रिमोट है, in that you are going to use the infrared rays. So keep in mind all that point. Well, ultrasonic test is used to detect and locate in the weldment external defect, internal roughness, none of the above. I think now all of you can answer that question. Why you are going to do the ultrasonic test? Ultraviolet, Rolex, here it is going, ultraviolet rays is going to be used in that camera. Clear hai? So yeah, ultrasonic test, this is comes under the this is NDT, नॉन डिस्ट्रक्टिव टेस्टिंग. ठीक है, ये हमारा NDT है. किसी चीज को अल्ट्रासाउंड करते हो बॉडी में, तो बॉडी यूज का होता है कि खराब हो जाता है. बॉडी में भी अल्ट्रासाउंड करते हो ना, तो आफ्टर अल्ट्रासाउंड बॉडी यूज का है कि खराब हो गया? ऑब्वियसली इट इज यूज. सो ऑलवेज कीप इन माइंड अल्ट्रासोनिक टेस्ट, you are going to be check is what, my dear friends? Internal crack, internal defect you are going to be checked. So keep in mind. Okay, so 39 B for Bombay is the right answer. अल्ट्रासोनिक वेल्डिंग बाइक की, हैव यू रिमेंबर और नोट? अल्ट्रासोनिक वेल्डिंग बाइक का की बनाते हो अल्ट्रासोनिक वेल्डिंग से. और अल्ट्रासोनिक मशीनिंग क्या बनाते हो बताओ? किसके लिए? ब्रिटल मटेरियल के लिए यूज करते हो. सारा अल्ट्रासोनिक की बात हो गई. अल्ट्रासोनिक मशीनिंग किसके लिए था जी? हार्ड एंड ब्रिटल के लिए ना. गुड. So that is the next question. The type of test in which capillary action principle is used. No, I think you can answer that question. No? What will be answer of that? 40. Question number 40 on your screen. C for Chennai. Huh, right. Just now you have seen. I think that question is repeated. Just so dye penetration test. C is a capillary. D is a dye penetration test. Chalo. In that way, the testing of material is completed. I think now another chapter started. Okay, that is another thing. Eddy current test is used to detect crack, hardness, conductivity, all of the above. Eddy current, current test. What will be answer of that question? What will be, my dear friends? Even just see ना, eliminate the option. Option हटाओ यार. कंडक्टिविटी क्या सर? मैकेनिकल होके कंडक्टिविटी हम जांच करेंगे? नहीं सर. मैकेनिकल वाले होके हम क्या करेंगे? हार्डनेस. सर ब्रिनल हार्डनेस था, रॉकवेल था, इससे हम हार्डनेस करते थे. एडी करंट से थोड़ी ना हार्डनेस करेंगे. हाँ, तो हम क्या करेंगे? इससे क्रैक की हम बात करेंगे. तो जो 41 क्वेश्चन नंबर व्हाट 41, द करेक्ट आंसर इज व्हाट? ए है ना. हार्डनेस के लिए हमारे अलग अलग है, तो हम क्रैक करेंगे. चलो, सो ए फॉर एप्पल इज द राइट आंसर. गुड. दैट इज द नेक्स्ट क्वेश्चन. बीकर हार्डनेस टेस्ट. देखो, बीकर हार्डनेस, ब्रिनल हार्डनेस, रॉकवेल हार्डनेस, दैट ऑल फॉर द हार्डनेस. Indented shape, yes, flat, spherical, conical or pyramid. Yeah, that time you can answer that question. What will be answer in case of beaker hardness test? Indented shape. Yes, my dear friends, pyramid, right? Pyramid, right? Now tell me, spherical किसके लिए था? अरे बताओ, spherical किसके लिए था बाबा? अरे tell me, which for spherical? Spherical किसके लिए था? याद नहीं, अभी भूल गए हो. Tell me, conical किसके लिए था? Comment all that. फ्लैट नहीं था सर, वो तो फर्जी का है. ये सब था भी. तो चलो, सारे को बताना है आपको. चलो, गुड. ये कुछ इस टाइप का होता है, देख रहे हो. मैंने लाया था डायग्राम थोड़ा आपके लिए, ताकि विजुअलाइज हो सके चीजें, है ना. यू कैन बी एबल टू विजुअलाइज लाइक दैट. बट यही है, कॉलेज में तो आप लोग टेस्ट किए ही नहीं हो. बट ठीक है, कोई बात नहीं. अभी अपने को काम चलाना है सर, उतना हो जाए, बाद में आके देखेंगे. तो कुछ इस टाइप से दिखेगा आपको, एंगल वेंगल भी आ जाते. चलो, now my dear friends, that is the question from the, I think, alloying of the element. 18 stainless steel consists of. बहुत बार ये क्वेश्चन पूछा जाता है. Several times this is going to be asked. अच्छा, रोलेक्स ने किया है. रोलेक्स, यू आर मनीष. हाँ, कौन है यार? ब्लैक पैंथर है. अच्छा, ब्लैक पैंथर. चलो ठीक है, कोई बात नहीं. 18 स्टेनलेस स्टील कंसिस्ट ऑफ. 18% क्या हो जाएगा इसका आंसर? क्वेश्चन नंबर 43. क्वेश्चन नंबर 43 ऑन योर स्क्रीन. 18% chromium, 8% what? निकल। 18% क्रोमियम, 8% निकल। अच्छा, ये सब जो बता रहा हूं दोस्त, दिमाग में पूरा बैठा लो, यहां से बाहर नहीं है, जो भी इंपोर्टेंट है मैं लेके आ ही गया हूं, तो बैठा लो। 18% क्रोमियम, 8% निकल, सो दैट इज द मीनिंग ऑफ 18-8 स्टेनलेस स्टील। 1% वैनेडियम भी होता है, 18-8-1, तो 1% हम वैनेडियम भी यूज करते हैं, इस तरह से होता है। This is the next question. Corrosion resistance of, I think everyone can answer that question. Very easy question. Several times it is going to be asked. How I can increase the corrosion resistance of stainless steel? By adding chromium, carbon, vanadium or copper. What will be answer of that? 44. 40, हाँ यार ग्रुप में मैं दे देता हूँ। अब ठीक है, पता नहीं आप लोग कौन किस ग्रुप में हो, मेरे पास जो ग्रुप है आई एम गोइंग टू शेयर द पीडीएफ इन दैट ग्रुप। अब इसके बाद मुझे नहीं पता यार कौन कहाँ कहाँ हो आप लोग। वी कैन टॉक टू द मैनेजमेंट, दे विल हेल्प यू आउट इन दैट। सो देखो, सी माय डिफरेंस, कोरोजन, सी से कोरोजन, सी से क्रोमियम। Always keep in mind, chromium is going to be increase the corrosion resistance of the steel, and this is called stainless, or you can say the stainless steel. You know by difference, basically three types of steel. You can say simple steel. In simple steel, you get the iron carbon only. In case of alloyed steel, we can get the iron carbon and any other alloying element. Any other alloying element we can get the. So stainless steel is a type of alloyed steel. क्योंकि यहाँ पे हम आयरन कार्बन के बाद क्रोमियम भी मैंने ऐड किया है, राइट? फाइन। दिस इज कॉल्ड मोनल मेटल इज निकल जिंक एलॉय, कॉपर जिंक एलॉय, निकल कॉपर एलॉय, कॉपर टिन एलॉय। मोनल मेटल इज व्हाट इज मोनल मेटल? रोलेक्स। देखो क्या फास्ट करें यार, लेकिन चलना है ना, टाइम तो देना है ना, जितना मुझे जितना टाइम देना है। हाँ, ऐसे कैसे हो सकता है सर? What time is required, I will go through like that, na? Everything need to discuss. Monel metal is what? Everybody? Yes, my dear friends. In case of monel metal, it is a nickel copper alloy. Always keep in mind, nickel copper alloy is called monel metal, whatever you can pronounce. So it is nickel copper alloy. C for Chennai. This is called monel metal, and I think that type of question they may ask day after tomorrow. Okay, so be ready for that. Next, brass is an alloy of. What is the alloy of brass? Copper zinc, copper tin zinc, none of the above. What will be brass? Question number 46 on your screen. A for apple. And what is bronze? One is called brass. Usually a student confused. Brass, another one is bronze. ना, ब्रास और ब्रॉन्ज में बहुत कंफ्यूजन होता है बच्चे को। आई हैव सीन, मैं देखता हूं बहुत कंफ्यूजन होता है ब्रास एंड ब्रॉन्ज। माय डियर फ्रेंड्स, ब्रास ऑलवेज कीप कॉपर Cu प्लस जिंक, राइट डाउन पूरा जिंक। सी हाउ मेनी लेटर इन द ब्रास? जस्ट वन थिंग आई वांट टू टेल यू, हाउ मेनी लेटर इन द ब्रास? 1 2 3 4 5 लेटर। हाउ मेनी लेटर हियर? ब्रॉन्ज इज ऑलवेज मेड बाय कॉपर एंड टिन, कॉपर एंड टिन, कॉपर एंड टिन, कॉपर एंड टिन। ब्रास हिंदी में क्यों क्या बोल रहे हो पूछ लो। चलो देखो इधर, कॉपर एंड जिंक। नो माय डियर फ्रेंड्स, सी इन ब्रॉन्ज 6 लेटर इज देयर। ऑलवेज कीप इन माइंड इट इज मेड बाय 5 लेटर्स। कॉपर एंड टिन CuTin 5 लेटर, इट इज 6 लेटर। ब्रास 5 लेटर, 1 लेटर ज्यादा करो। कॉपर ZINC, जिंक 6, कितना है 6 और यहाँ 5। ये मैं यूज करता हूँ जनरली बच्चों को क्लास में बताने के लिए, क्योंकि बड़ा कंफ्यूज करता है ब्रास एंड ब्रॉन्ज में। सो ब्रास, कॉपर, जिंक, जस्ट गो थ्रू दिमाग, BRASS 1 2 3 4 5 लेटर। सो आंसर शुड बी 6, कॉपर एंड जिंक। ब्रॉन्ज इज 6, आंसर शुड बी 5, कॉपर एंड टिन। हैव यू फॉरगेट एवर? अब तो नहीं भूलोगे ना कभी, पक्का? बी श्योर, अब तो नहीं भूलोगे, अब नहीं भूलना है दोस्त कभी भी। सो ब्रास पूछा गया तो कॉपर एंड जिंक हो जाएगा, अगर ब्रॉन्ज पूछा जाता तो कॉपर एंड टिन हो जाता। फाइन। So 46 फिलहाल A for apple is the right answer. Question number 47 on your screen. Toughness of steel increased by adding. How you can increase the toughness? How you can increase the toughness? अरे कांच से बोलते हैं, कांच से, हिंदी में कांच से बोलते हैं कुछ, रोयल शर्मा कांस्य कुछ ऐसे करके बोलते हैं ना, ठीक है, कांस्य कुछ इस टाइप के बोलते हैं, ठीक है, देख लेना एक बार। Okay, what answer I am getting? 47. Question number 47 on your screen. Yes, my dear friends. Toughness, if you have to increase, na, always keep in mind you have to be at the nickel. So that was the few things you have to remember. Nickel is going to be increase the toughness, Baba. Nickel going to increase the toughness. Sulfur is little bit going to increase the machining और मशीनेबिलिटी, नॉट मोर। मैग्नीज होता है मशीनेबिलिटी के लिए, बट सल्फर से लिटिल बिट अपना काम चल जाता है। बाय एडिंग क्रोमियम यू कैन इंक्रीज द कोरोजन रेसिस्टेंस, ठीक है, ठीक है, क्रोमियम बाय इंक्रीज द दैट। टंगस्टन का भी यूज होता है, मैं भी देखूंगा। सो दैट इज एलोइंग एलिमेंट चैप्टर दैट आई एम गोइंग टू डिस्कस हियर। आफ्टर दैट आई विल गो थ्रू द आयरन कार्बन डायग्राम। रेलवे लेयर्स आर नॉर्मली मेड बाय माइल्ड स्टील, निकल, एलॉय स्टील, हाई कार्बन स्टील और टंगस्टन स्टील। रेलवे लेयर किसका बना होता है जी? आंसर दैट क्वेश्चन। क्वेश्चन नंबर 48 ऑन योर स्क्रीन। रेलवे का जो पटरी होता है किसका बना होता है? माइल्ड स्टील, निकल, एलॉय। निकल तो नहीं, वी कैन एलिमिनेट सर, निकल इज नॉट सर, आई एम डैम श्योर। सर टंगस्टन इज नॉट सर, आई एम डैम श्योर सर, दीस टू आर नॉट पॉसिबल। सो व्हाट कुड बी पॉसिबल? माइल्ड स्टील सर, माइल्ड स्टील बहुत ज्यादा डक्टाइल होगा बाबा, बहुत ज्यादा डक्टाइल होगा। ट्रेन का जो गर्मी होता है ना उससे भी एक्सपैंड कर जाएगा वो। सो इट कुड नॉट बी सर, should be a little bit tougher also, they should have more strength sir, so that's why I'm going to prefer the high carbon steel। मुझे बताओ दोनों में किसके पास स्ट्रेंथ ज्यादा है? by adding the percentage of carbon strength increases ना, so high carbon steel का स्ट्रेंथ ज्यादा है, that's why I'm going to prefer the C4 चेन्नई, right, not A4 एप्पल। okay, mild steel नहीं करेंगे, नहीं तो पता चला इतना गर्मी होगा, they will get the little bit and elongate, right, so you don't have to do like that। okay, question number 49 on your screen। Babyit material are used for, पहले तो tell me what is babyit material। okay, one question I have, then I will discuss। meanwhile tell me the use, gear, bearing, bolt or clutch, where it is going to be used। हाँ पढ़ के तो आए हो तुम लोग, गुड। not reduce शर्मा जी, increase, right, yes, bearing material, babyit material generally used to making a bearing। have you remember various types of bearing is there? Hydrostatics bearing, hydrodynamic bearing, collar bearing, right, so all that type you are going to use the for the bearing। so babyit material for the bearing, B for babyit, B for baby, B for bearing, all are the same thing। 49 यहाँ पे कुछ मैं बता दूं एक बार बेबिट के बारे में। कंपोजिशन ये होता है, यहाँ पे थोड़ा इसको याद रखना, मैं भी देखता हूँ बेबिट मटेरियल पे क्वेश्चन है अपने पास। ओके, नाउ दैट इज द नेक्स्ट क्वेश्चन, ब्रॉन्ज। नाउ टेल मी द आंसर, व्हाट शुड बी द आंसर ऑफ दैट? ब्रॉन्ज में क्या क्या होता है? ब्रॉन्ज कंटेंट्स, व्हाट द ब्रॉन्ज इज गोइंग टू बी कंटेंट्स, टेल मी। आंसर फास्ट माय डियर फ्रेंड्स। इस बार आप लोग कंजूसी कर रहे हो आज लाइक वाइक में, पता नहीं क्यों। कल का भी सेशन है 5 बजे, ठीक है, होल मॉक टेस्ट ऑफ मैकेनिकल इंजीनियरिंग। So tomorrow again we'll meet with the same energy, with the same content and all are क्वेश्चन नंबर, कंटेंट अलग होगा जी, कंटेंट सेम थोड़ी ना होगा, है ना। बताओ ब्रोंज सर किसका बना होता है? सर ब्रोंज कितना लेटर है? 1 2 3 4 5 6। अच्छा इंग्लिश में 1 2 3 4 5 6। सो व्हाट शुड बी सर? कॉपर एंड टीन शुड बी सर, कॉपर एंड टीन शुड बी सर, बट इन द ऑप्शन नो कॉपर टीन इज देयर। हाउ इजी सर। हाँ, डी फॉर दिल्ली। इसमें तरीका देता हूं, मुझे आप पे पूरा भरोसा है ना, क्योंकि मास्टर भी कभी विद्यार्थी था, तो पूरा भरोसा है हमें कि क्या गलती करोगे। नन ऑफ द दीज इज द राइट आंसर। ब्रॉन्ज 6 लेटर, 3 काम होना चाहिए था, ऑप्शन में एक भी नहीं है कॉपर एंड टिन, सो नो वन इज द राइट आंसर। राइट, गुड, मजा आ रहा है जी इस बैच में अभी। ओके, सो दैट इज द नेक्स्ट क्वेश्चन ऑन योर स्क्रीन। व्हाट द क्वेश्चन इज दैट द परसेंटेज ऑफ कार्बन in gray cast iron in the range of ग्रे कास्ट आयरन में क्या देखो, ऑप्शन भी एलिमिनेट करना सीखो। सास भी कभी बहू थी, बिल्कुल सही जा रहे हो। सो क्वेश्चन नंबर 51 ऑन योर स्क्रीन। Now eliminate the option. Sir, cast iron na sir. Cast iron na sir. Sir, A cannot be sir. Very less sir. It is steel. It is not a cast iron sir. हाँ sir, D cannot be sir. D cannot be sir. 8 to 10%. हाँ 6% से ज्यादा तो मुश्किल है सर, तो फर्जी है सर, फर्जी है। हाँ सर ये बात कर रहा है। अच्छा बी सर 1.25 से 1.75 सर, इट इज वेरी क्लोज टू स्टील सर, इट इज आल्सो वेरी क्लोज टू स्टील सर। हाँ या because approximate 2% I am considered as a, you know what, steel percent of carbon approximate to 2%. So sir it cannot be sir, right? So what could be? C for Chennai only. So देखो, that's why I used to say ना, use little bit mind, don't try to by heart all the things, just use। इतना कम तो हो नहीं सकता है, ये तो होता ही नहीं है। 2% तक approximate I consider the steel. So what option is left? C for Chennai is the left, and yeah, all of you have given the right answer. Great. So my dear friends, in that way 1/3 of our journey it completed. Okay, today you have 130 question. That is the next question from the engineering material. One chapter is there, different types of, or you can say the what, advanced material. So that question from the advanced material, or we can say the composite material, ceramic, polymer, from that segment. Question: a material whose molecular property allow considerable reversible extension. Okay, reversible, right, extension is referred as polymer, plastic, elastomer, and isomer. So question number 52 on your screen. मुझे थोड़ा पानी पीने दो तब तक, आंसर बताओ। हो जाए एक बार। Okay, so my dear friends, material whose molecular property allow considered reversible extension is referred as, that is called elastomer. So C for Chennai is the right answer. And yeah, good thing is that most of you have given the right answer, not all. Just read once. The electric process of steel making is especially adopt to the electric process of steel making especially adopt to alloy and carbon, magnet steel, high speed steel. Okay, all of the above. What could be answer of that question, my dear friends? Question number 53 on your screen. The electric process, we talk about electric induction something. So we can go alloy and carbon tool steel, magnet steel, all we can do. So keep in mind, D for Delhi is the right answer this time. Just try to remember that point. All not more important, that thing I have taken just for you. Next, thermoplastic R, very very important. VVVI. The question has been asked in 2025 31st May exam. 31st May exam. Okay, from the thermosetting and thermoplastic. इसीलिए I have taken the same question, same type of question, or wrote right same. ठीक सोचो, अगर इतना सोचे हो तो बिल्कुल सही सोचे हो यार। कौन है? Okay, you have think the right. So what is thermosetting? What answer is there? Thermoplastic, non-linear polymer in which rise temperature increase the plasticity. Linear polymer in which rise in temperature increase the plasticity. Linear polymer, temperature has no effect on the plasticity. None of the above. My dear friends, always keep in mind there is two types. One is called thermosetting, another one is thermoplastic polymer. In case of thermosetting, you talk about thermoplastic, तो ये होता है linear polymer in which temperature increase the plasticity. So that is the example of thermosetting. Now suppose in the question instead of thermosetting thermoplastic होता, तब आंसर क्या होता? Instead of thermosetting, let's assume instead of thermoplastic, let's assume thermosetting is there, then what could be answer? Then answer will be C4 Chennai. So keep in mind thermosetting is what I will come in the question, जिसको हम setting नहीं कर सकते हैं. Okay, see my dear friends, thermoplastic is that polymer, जिसका property can be changed. The property can be changed after heating and cooling. But if you talk about thermosetting is that जिसका setting नहीं हो सकता. क्या बात कर रहे हो? सेटिंग नहीं हो सकता क्या मतलब? Thermosetting is that polymer whom setting cannot be possible. Setting means अदर दूसरा सेटिंग वेटिंग नहीं है यहाँ पे, मतलब जिसको मैं ठंडा करके फिर हम सॉफ्ट नहीं बना सकता. एक बार अगर ये हार्ड हो गया, सो दिस इज हार्ड फॉर ऑलवेज. दैट इज द मीनिंग ऑफ थर्मोसेटिंग, जिसका सेटिंग नहीं किया जा सकता है. थर्मोप्लास्टिक, जिसका सेटिंग किया जा सकता है. दैट्स व्हाई लीनियर पॉलीमर व्हिच राइज टेंपरेचर इंक्रीज द प्लास्टिसिटी. सेटिंग कुड बी पॉसिबल, बट इन थर्मोसेटिंग इट इज नॉट पॉसिबल. राइट, सो दैट यू हैव टू बी रिमेंबर. तो टेक्निक भी है दोस्त, है कि अपने लोग टेक्निक भी रखते हैं ना, ताकि दिमाग में याद रहे भाई. नहीं तो एग्जाम में इतना सारा चीज कहां से याद रखेंगे हम लोग. चलो, वेल, सो दैट इज द नेक्स्ट क्वेश्चन. व्हिच ऑफ द फॉलोइंग इज द ओके दिस टाइम थर्मोसेटिंग प्लास्टिक? पॉलीथीन, बेकेलाइट, पॉलीविनाइल क्लोराइड और नेलॉन. इसमें से कौन सा थर्मोसेटिंग है? जिसका सेटिंग नहीं होगा वही थर्मोसेटिंग है. राइट, जिसका सेटिंग हो गया, these are thermoplastics. चलो, तो ठंडा लगने लगा, मैं थोड़ा ब्लेजर पहन लूं. लोग जो पहन लेता हूं, लाइट वाइट कटा है. ओके, गिव आंसर दैट क्वेश्चन. क्या आ रहा है? बेकेलाइट. व्हिच ऑफ द फॉलोइंग इज अ थर्मोप्लास्टिक, थर्मोसेटिंग प्लास्टिक. ठीक है, दोस्त. यस, बेकेलाइट इज द राइट आंसर. थैंक यू. See my dear friends, here means always keep in mind bakelite is here. I am came with that. Please remember that thing at least till the exam. देखो, many common plastic thermoset they include, that all are thermosetting. Bakelite, that all are thermosetting. ठीक है, and thermosetting. Okay, thermoplastic I will give in the some another question. So here we can say a thermosetting plastic polymer that irreversible. See here, thermosetting जिसका setting नहीं किया जा सकता means it is irreversible. So thermosetting plastic is a polymer that is irreversible, becomes rigid when heated. Such a material is also known as thermoset or thermosetting polymer. Initially the polymer is liquid or soft solid. और ये कुछ इसका एग्जाम्पल है जो आप देख सकते हो. रबर, पोलिस्टर, मेलाइन, बेकेलाइट, silicon and epoxy. These three are mainly going to ask in the exam. So try to remember that name. Right? Okay. So keep in mind that name. That is the next question. Addition of tungsten in steel. What tungsten did in steel? अरे यार, what answer? Addition of tungsten improve strength at elevated temperature, improve corrosion resistance, decrease hardness, improve coarse grain. So what will be 56? I am getting answer what? 56, A for apple. Yes, my dear friends, keep in mind by adding the tungsten, they are going to improve the strength at elevated temperature, right? So just talk about in tungsten P is there, in temperature T is there. My dear friends, if that you are remember ना, it will be remembered for a longer time. और वैसे जब रटने बैठ जाओगे ना, मुश्किल होता है दोस्त. हम भी तो विद्यार्थी थे. So just think tungsten, temperature, right? That is the something मिलता जुलता सा लग रहा है ना. So in that way improve strength at elevated temperature. I am going to use the tungsten. तो है कुछ तरीका है दोस्त, इसे हम याद रख सकते हैं. बाद बाकी थोड़ा मुश्किल हो जाता है, right? So in that way you could be able to improve the strength at elevated temperature. Yeah, strength is going to mean to at a temperature. So you talk about temperature. Good. So here for apple is the right answer. Everyone you have given the right answer. That is the question number 57 on your screen. Corrosion of metal involve physical reaction, chemical, both or none. What you can say corrosion? Which type of reaction we can say? It is corrosion reaction. दोस्त, तो कल नेट बचा के रखना शाम को 5 बजे के लिए, राइट? शाम को 5 बजे कल फिर मिलेंगे मॉक टेस्ट के साथ, जहां पे सभी सब्जेक्ट होगा, थर्मो, आरएससी, पावर प्लांट, आईसी, हीट ट्रांसफर, फ्लूइड मैकेनिक्स, हाइड्रोलिक्स मशीन, प्रोडक्शन इंजीनियरिंग, इंडस्ट्रियल इंजीनियरिंग, FEM, ED, all the subject question will be tomorrow at 5 p.m. So what answer I am getting here? Question number 57 on your screen. My dear friends, physical reaction and chemical. Listen. One thing I want to tell you one thing, my dear friends. Corrosion of metals which is involved, this is basically chemical reaction, right? How we can define the physical? देखो, जहां पर भी कुछ मास का रिएक्शन हो ना, जहां पर भी कहीं मास चेंज हो जाए ना, that is comes under the category of physical reaction. Right. So 57 you have given the before Bombay is the right answer. Come to the next question. That depends on the question, दोस्त. I cannot say anything like that, right ना? ऐसे हम कुछ नहीं कर सकते. That depends upon the question, which type of question or all that is there. तो ऐसे अभी मैं कैसे बोल दूं आपको कितना कर ही लो पक्का सिलेक्शन है? That all depends upon the question pattern, question, difficulties and all that. So if Tm is the absolute melting temperature, then the recrystalline temperature for the pure metal in terms of Tm is, for the pure metal you talk na, what will be answer of that question? Question number 58 on your screen. Pure metal, right? Actually it is happening how much? 0.7 to 0.8, 0.8 to 0.9, 0.6 to 0.7. नहीं यार इतना ज्यादा कहाँ होगा? मैंने क्लास में बताया था. How you are going to give C for Chennai? This is a lifeline. C for Chennai is the wrong answer. Answer now. If you have remember, I have told actually it is nearby the 0.5. Na D for Delhi is the right answer, Baba. Then just recrystallization temperature is right between 0.3 to 0.4 times of the melting temperature. Not like that. It बहुत ज्यादा हो गया फिर तो तुम upper कैसे करोगे? Hot working how you can do? अगर यही ज्यादा होगा then how you can do the hot working? Right? So D for Delhi is the right answer. 0.3 to 0.4. Okay? And for okay, that is another question. Teflon. What is Teflon? What is Teflon? What is Teflon, my dear friends? Lag होता है class. क्या बात कर रहे हो? Any other facing that difficulties? Yeah. Question number 60. What is Teflon? Question number 60 on your screen. Teflon is thermoplastic or thermosetting. देखो thermosetting का I have given the list. Teflon था नहीं था sir. So thermoset carbon, no, it is not a thermosetting. So it cannot be here. Thermoplastic, yes, B for Bombay is the right answer. Teflon is a thermoplastic, not a thermosetting. Thermosetting also known as thermoset, right? So B for Bombay is the right answer. Teflon, thermoplastic है, fluorocarbon polymers, yes. Okay, that is the question. Okay, this is the next question. ... resin repeatedly softened by heat and hardened by cooling. Oh, that is a very easy question. जिसका सेटिंग नहीं होगा और थर्मोसेटिंग जिसका होगा वो थर्मोप्लास्टिक. तो किसका सेटिंग नहीं होगा जी? यहाँ पे देखो सेटिंग हो रहा है कि नहीं हो रहा है? हो रहा है कि नहीं हो रहा है सेटिंग? हो रहा है ना सर? रिपीटेडली सॉफ्टेन एंड हीट एंड हार्डन मींस हो रहा है, चेंज हो रहा है. So this is comes under the category of thermosetting or thermoplastic. Yes, B for Bombay is the right answer. B for Bombay is the right answer. And yeah, that time everyone have given. सब सोचता है मेरे को सेटिंग होना है मेरा, है ना, मेरा सेटिंग होना है. That's why all have gone with the option B. I know tendency of engineers, huh? Good. B for Bombay is the right answer. Especially mechanical guys, huh? So, just go through one's PDF. Whatever I have told you, everything is written there. Okay, that is the next question on the screen. Ly containing 65 to 70% of nickel. What it is called? Monel metal, white cast iron, stainless steel or brass. Okay, from the option you can answer that question. Option से answer कर सकते हो इसका. आंसर यार, स्टिल 50, मोर देन 50%. चलो चलो आंसर बताओ, आंसर बताओ, एग्जाम देखे और रोलेक्स. मोनल मेटल, यस. सुनो, निकल ना, ऑप्शन एलिमिनेट करो यार. कास्ट आयरन में कहां से निकल की बात करेंगे सर, स्टील. मतलब मजा नहीं आ रहा है सर, हमें भी नहीं आ रहा है मजा. तो आंसर क्या हो जाएगा 62 का? मोनल मेटल, राइट. ए फॉर एप्पल इज द राइट आंसर. ब्रास क्या ही होगा. चलो, तो क्वेश्चन नंबर 63 ऑन योर स्क्रीन इज एन एग्जांपल ऑफ थर्मोसेटिंग रेसिन, पीवीसी, एबीएस, मिथाइल क्राइट, फिनॉल फॉर्मल्डिहाइड. व्हाट विल बी आंसर? इज एन एग्जांपल ऑफ थर्मोसेटिंग रेसिन. थर्मोसेटिंग की बात हो रहा है दोस्त. You can say, sir, why you are going to focus? Because last time question has been asked from that segment. That's why I have taken 5 questions from that only. As I told you, how we can predict? I see their question pattern, what they are going to be asked, and accordingly I am to frame the question. So if you go through the 31st my question, they have asked on the thermosetting and thermoplastic. That's why different question I have taken here, so that if they are going to ask that time, you have to do that. Okay. So in example of thermosetting, क्या आंसर लगा रहे हो दोस्त? D for Delhi. Question number 63. PVC thermosetting you talk, phenol formaldehyde. Yes, D for Delhi is the right answer. Here I have given some more name: thermosetting, thermoplastic. We can say most frequently used thermosetting resin polymers. All this name: phenol, vinyl, silicone, all that. Okay, select the following ascending order of cutting material hardness. Select the from the following ascending order of cutting tool material hardness. Okay, ascending order. Fine. What will be answer of that question? देखो कौन है यार ये. Language is not should be barrier. Mr. Noon, whatever your name is there. Main thing is that here lot of students from the south try to understand my point. Okay, even I want. Okay, I will go through the Hindi. But most of the guys here and because BEL exam is going to be conducted throughout the India, so both type of student is there. And I know my English is not as much as strong as you expect from other educator. But yeah, language they are not a major factor here. And not should be for engineers. हमें तो समझना है भावना यार, इतना समझो. And if I speak in Hindi na, no one south guys can understand. Mister, so select from the following ascending order of cutting tool material. क्या आंसर दे दो? 64. What answer I am getting? B for Bombay, D for Delhi, C for Chennai. Okay, all option is coming. All option is there. A is left. My dear friends, high carbon steel, high speed steel, ceramic or diamond. Always keep in mind the correct answer is what? D for Delhi. High carbon steel. After that, we can say the high speed steel. Cutting tool material of hardness. Ascending order, na? Yeah. Then it will be the ceramic and then diamond. So D for Delhi is the right answer. Try to remember. Okay. Ceramic, because they can sustain their hardness even at a high temperature. That have good quality they have. Polymer can sustain. If any material, if you increase their temperature, na, hardness decreases, right? Hardness decreases. But the polymer have some better. They can sustain, because if cutting velocity बढ़ेगा तो temperature ज़्यादा rise होगा ना, तो फिर hardness कम हो जाएगा, tool टूट जाएगा. तो in that case you are going to use the ceramic. If you have diamond is a little bit costlier, so हमारा काम diamond, हमारा ceramic हम चला लेते हैं काम. What type of material are ceramic? Ceramic कौन सा? इंसुलेटर है, कंडक्टर है, सेमीकंडक्टर है और सुपर कंडक्टर. No, not possible, dear. No, not possible. Answer that question. What will be answer? Question number 65. Yes, my dear. Ceramic is a insulator. Good. Insulator means which type of bond is there? They may ask in ceramic which type of bond is there? Covalent or ionic? Okay, tell me in ceramic which type of bond? Covalent or you can say the ionic. Which type of bond is there? Anybody can tell me? Even that question they can ask. This is the basics. Right now? Yes. Well, come to the next question, my dear friends. Question number 66 on your screen. Thermosetting plastic have in general. What in the general? Molecular chain and slip past, be a ceramic shell, all ceramic and glass, a kind of ceramic, okay, have a monolithic crystal structure, have a long range crystalline lattice structure. What could be answer of that question? Mostly covalent. Rahul, you are right. You are right. Rahul, you are right. Question number 66 on your screen. Thermosetting plastic have in general. What answer? What answer you are going to be give? This will be the have no long range crystalline lattice structures. It don't have any lattice structure. So D for Delhi is the right, my dear friends. Okay, remember at least till the exam. After that, come in the interview session, ask how it is happening, sir. Just meanwhile, remember, have no long range crystalline lattice structures, because last time they have asked question from that segment. So I think in that way that chapter completed. German silver contains, what the German silver contains? What will be answer of German silver? What will be answer of that? What will be answer of that question? German silver. Answer everyone. See, my dear friends, if you talk about German silver, na, here keep in mind, copper is going to be vary from 50 to 61.6, zinc from that, nickel from that. So this is their range which is going to vary in that. Okay, now my dear friends, I am going to take the question from the iron carbon. But my dear friends, I want to tell you, before moving to the iron carbon, I am going to cover their important concept or content, and that will help you to solving the questions. Okay, so अब जो question है हमारे पास, that is from the iron carbon diagram, iron carbide diagram, and it is most important. So rather than saying in all the question कि रट लो, what I am going to do, I will take your 5 to 10 minutes, not more than that. I am going to be shown here iron carbon diagram, and whatever important point is there, I will tell you, remember in your brain, and easily you could be able to solve that question. So before moving to that question, give me 1 minute, my dear friends. I am going to be see you iron carbon and all important point regarding that. Then I will come the question rest whatever is left there. Iron carbon diagram new, and whatever important thing is there, I will tell you to ask to. अरे इतना छोटा कैसे हो गया ये? Tell me, is it visible? Visible everyone? Is it visible to all? Visible ना? अरे आयुष पहले एग्जाम तो हो जाने दो, एग्जाम तो हो जाने दो, देन ओनली यू कुड बी एबल टू. ऐसे हम लोग क्या है, भगवान है जी, जब तक डाटा नहीं आएगा हाउ यू कैन से. एग्जाम होने दो. आपको पता है 20 तारीख को हमारा लाइव सेशन है यहाँ पे, जहाँ एनालिसिस होगा, देन वी कैन लिटिल बिट कुछ हम बता सकते हैं, फिलहाल कुछ नहीं बता सकते हैं ना. व्हाट कुड बी कट ऑफ एंड ऑल दैट, अनलेस एंड अनटिल not getting the data from the student, question pattern, question difficulties, lot of factors there. So iron carbon diagram, here this is metastable. First time they are going to ask, is it equilibrium or unstable, or equilibrium or unequilibrium or non-equilibrium. So first point about the iron carbon diagram, it is a stable equilibrium. It represent iron cementite system. Okay, carbon content in the range, carbon content 0 to 6.6% weight percentage. You know, my dear friends, if you are going to increase the percentage of carbon more than 6.67%, what is happening? They are not going to be just ये सरफेस पे आ जाएगा, भरेगा ही नहीं. क्योंकि अभी मैंने आपको बोला, मैंने क्या बोला कि कार्बन कहां पे जाता है, कार्बन कहां पे जाता है, टेल मी, कार्बन कहां पे जाता है. सो अगर हमारे पास ये आयरन है, दिस इज द आयरन मॉलिक्यूल्स, राइट, तो कार्बन कहां पे जाएगा, कार्बन गोज एट इंडस्ट्रियल साइट, कार्बन यहां पे आके बैठेगा. कार्बन का एटम छोटू है, स्मॉलर साइज, कार्बन इज स्मॉलर साइज, तो यहां पे आके बैठ जाएगा. अब मुझे बताओ, ये जगह कम होगा या बहुत स्मॉल जगह है ना, तो कितना आप दे सकते हो, बहुत कम दे सकते हैं. इसीलिए मैक्सिमम कार्बन दैट आई कैन ऐड इट इज 6.67%. इसके बाद अगर मैं ऐड करूंगा तो ये सरफेस पे आ जाएगा, दिखेगा. carbon. Oh, carbon hai. That's why after that I am not going to be add. Applicable mainly in the steel and cast iron. Now if you talk about here, so keep in mind that is the maximum you can add. Phase in iron carbon, first thing is coming out to be ferrite. Ferrite is also known as alpha iron. Alpha iron means it always exists at a room temperature, first thing, or less than the 910 degrees Celsius. So ferrite is alpha iron. What is their structure? Keep in mind, ferrite structure is what? BCC in the structure. What another point? This is always soft, and since percentage of carbon is lesser, so it is ductile, and since it is at a room temperature, sir, means below the Curie temperature, sir, so it is magnetic. Now the question they may ask, if ferrite is exist at which temperature? So ये below 770 डिग्री सेल्सियस पे आपको मैग्नेटिक प्रॉपर्टी शो करेगा. Maximum percentage of carbon that you can add, this is 0.02% of carbon at a temperature of 727 degrees Celsius. Question will ask, what is the maximum percentage of carbon that can be added in a ferrite? That will be 0.02 degrees Celsius at 727 degrees Celsius. Or if you talk about at a room temperature, so room temperature it will be 0.008%. Now we can ask, sir, why it is less at room temperature? Now my dear friends, just one thing I want to ask. Suppose this is the material, this is at a room temperature, case 1, okay, and this is at a higher temperature. Now tell me my dear friends, in which case more carbon can goes at industrial site, in case 1 or in case 2? think ना, सोचो ना. अगर देखो जब कोई चीज ठंडा रहेगा तो मॉलिक्यूल्स पास रहेगा या दूर रहेगा? थिंक अबाउट, इफ एनीथिंग इज कूलर, मॉलिक्यूल्स विल बी क्लोजर. हाँ, पास रहेगा सर. इफ एनीथिंग इज हीट, मॉलिक्यूल्स दूर रहेगा सर. हाँ, इफ मैं हीट करूंगा तो मॉलिक्यूल्स विल बी फार एंड फार, सो मोर कार्बन कैन बी एडेड. यस सर. So here more carbon can be added. That's why at higher temperature solubility increases. And if you talk about here, since ठंडा है सर, ठंडा है तो मॉलिक्यूल्स विल बी क्लोजर, कम पे होगा तो मैं यहाँ पे कम कार्बन ऐड करूंगा. एंड दैट्स व्हाई माय डियर फ्रेंड्स, अगर तुमको कहीं पे भी कंसंट्रेशन बढ़ाना होता है कार्बन का तो आप इसको हीट करना स्टार्ट करते हो. यू माइट हैव सीन चाशनी, कभी खाए हो, क्या बोलते हो, जलेबी, चाशनी, चाशनी, राइट. क्या करते हो, पहले पानी को हीट करते हो. क्यों? बाय हीटिंग दैट द solubility of the sugar increases. That's why you are going to do. That's why at 0.02 we can add at the 727 and 0.008 at the room temperature, and you can see very less at the room temperature, right? So that point you have to keep it in mind about the ferrite. What about next is what? Austenite. This is called gamma iron, right? Their structure is FCC, and this is non-magnetic in the nature. Well, so my dear friends, keep it on austenite. If you talk about, that is FCC structure, non-magnetic, and what the maximum temperature, what the maximum that you can add the percentage of carbon, all are important. This is 2.11% of carbon at 1147 degrees Celsius. My dear friends, there is a diagram, iron carbon diagram is also I have, but since it is at the bottom, so it will be difficult to go each and every time. Here, this is your iron carbon diagram, right? Can I zoom out? Visible now? Visible? So see here, this we can say 0.83. Before that is called hyper eutectoid steel, and after that you will get the hyper, it is hypo, all that. So I will see here. Keep in mind the important point that I am going to be see here. After that I will come on the diagram, and then we will come to the question. So keep in mind that point, that is important. Going to be asked, what is the maximum percentage of carbon that you can add in the austenite? 2.1% at temperature 1140 degrees Celsius. Third thing is what? Cementite. What you have to be keep in the mind about the cementite? Cementite is hard. Cementite is hard. It is brittle. Cementate is hard and brittle. Carbon content, they can maximum content 6.67%, responsible for the hardness of steel. Now if you talk about delta iron, this is BCC in the structure, exists at a very high temperature. Maximum solubility here 0.9%, 0.09. So that point you have to be keep in mind. Perlite, microstructures, okay. If you talk about lidubulite, so this is basically austenite plus cementite. Okay, so that thing. Next, you talk about eutectoid point, very very important. This is very very important. Even I have written here, very very important. They will ask, what is eutectoid point? What is eutectoid? Okay, need to zoom, huh? Okay. No, fine. Now is it fine, kya? Right? See, so here we can say, if you talk about critical point or some line, eutectoid point, here composition is 0.76% of carbon. Eutectoid point will get at a 727 degrees Celsius. And yeah, most important, you have to be remember that what reaction is going to be take place at a eutectoid point. So always keep in mind, at eutectoid point you have austenite, and it is going to be converted in the alpha iron. This is called ferrite and cementite. At you can then ask, what is happening at the eutectoid point? So we can say, sir, austenite is going to be converted in the ferrite and cementite. Keep in mind, right? Structure form is perlite. Okay, next is what here, eutectic point. At eutectic point, what is happening? One liquid is converting in gamma iron plus of cementite. Composition 4.3% of carbon. At which temperature eutectic point is going to be take place? 1147 degrees Celsius. This is going to be take place at a 1147. I will see all that in the question. And here what is happening? Eutectic liquid is going to be converted in gamma and Fe3C, means one. And a structure form here, it is called, whatever structure, this is called radiography. Next is what? Peritectic point. Peritectic. So peritectic, what is the composition? 0.16% of carbon. Peritectic reaction occur at temperature 149 degrees Celsius. Here delta plus liquid iron gives the what? Gamma. Now that point you have to be keep in mind. Hypoeutectoid steel, when percentage of carbon is less than 0.76%, 0.76% less, it is called hypo. And it is more than 0.8%, 0.85, whatever you can say, then it is called hyper eutectoid. Hypoeutectoid, percentage is less than 0.7, 0.8 you can say, and it is more than 0.8, it will be called hyper. So keep in mind, we will see that thing all in the question format also. Okay, so here what is happening? Phase is ferrite and perlite. Eutectoid steel, 100 at eutectoid 100% is what? Perlite is going to be takes place. Hypereutectoid steel, that is the percentage of carbon 0.6, 0.8, whatever is there. Phase is perlite plus cementite. Okay, cast iron range. Okay, as I told you, steel 0 to 2.1%, and it is cast iron. If the percentage of carbon just more than 2%, it is considered as a cast iron. Okay, so that is the sum. I have given the exam favorite point, eutectoid, temperature, upper, all that. Here my dear friends, in this diagram I am coming, so try to remember all that points, all RVBA right now, because you know lack of time, so I'm just going to give the important data to you have. My dear friends, that is the diagram you can see, right? This is, here you can say this is called perlite pellet. Okay, two things usually even I used to ask in the interview when I'm going to take. This is called baba upper critical temperature. ठीक है बाबू? This is called upper critical temperature. This is called lower critical temperature. So lower critical temperature, in case of iron carbon diagram you talk, it is independent from the percentage of carbon. Various times it is going to be asked, to which of the following critical temperature? No, depends on the percentage of carbon. So this is, you can say, straight line. This is called lower critical temperature, and it is always 727 के approx होगा, and it is independent from the percentage of carbon. But if you talk about upper critical temperature, see, okay, मैं इसको before that, यहाँ से यहाँ तक, this is called hypoeutectoid, and this is called hyper. So this is called upper critical temperature for hypo. This is called upper critical temperature for hypo, and it is going to depends on the percentage of carbon. And this is called upper critical temperature in case of hyper. This is also going to depends on the percentage of carbon. But if you talk about lower, so it is independent from the percentage of carbon. Okay, so my dear friends, whatever you have read, I am going to be see some question on that. Let us start with the question then. Perlite is a combination of, what is perlite? Perlite, what do you mean by perlite, my dear friends? Answer everyone. What do you mean by perlite? Can you answer? Just now you have seen. Yes, perlite is a combination of ferrite and cementite. It is a combination of ferrite and cementite. See, when I have start discussion, the learning content, most of you have gone, हाँ यार ऐसे कितना रटोगे, कुछ तो आइडिया होना चाहिए ना, how much you can buy her in one day, हाँ? So it is a ferrite and cementite. 68. Here always keep in mind my difference. Perlite consists 87% of ferrite. Perlite consists 87% of ferrite and 13% of cementite. Always keep in mind. Perlite 87% ferrite and 13% of cementite. Cementite means Fe3C. Next question. Which of steel is softest and least strong? Which of the following constituents of steel is softest and least strong? When it will be soft? When percentage of carbon is less or hard? Just listen. When it will be soft? So the percentage of carbon कम होगा. Just think. When percentage of carbon will be less, क्योंकि percentage of carbon is increases, it becomes hard. So now go through austenite, perlite, cementite or ferrite. What could be answer? What could be answer? Question number 69 on your screen. Baba, where the percentage of carbon is less, 0.008%, Baba, it was ferrite. Arey Baba, austenite. Austenite is a very hard. Okay, sometimes they may ask which of the following is not going to find over the iron carbon. So austenite you are going to get over the time martensite. Okay, austenite no, but martensite you are going to be get. So when the percentage of carbon is less, it is become soft. So question is softest and least strong. So answer will be the ferrite, Baba. No perlite, no cementite, no austenite. Right? Keep in mind. Martensite it will be, who have asked? Rahul, martensite. I will come on that because very fast rate of cooling. I have given everything about the ferrite. Just read all that. I will share all that PDF. And I want to make sure, my dear friends, if they are going to ask, it will be from that segment. Really, I am telling you. Why I am so much of sure? Because whatever different types of question there, I have taken all. So why I will not be sure about that? After exam, we can say question was from that or not. That is the next question. What is the crystal structure of alpha iron? Now I think everyone can answer. Body centered. That question no one can make a mistake now. What will be answer? Question number 17 on your screen. Question number 70. Everyone answer. Body centered cubic. Right, BCC. So my dear friends, in that way, half of journey is completed now. I think half of journey, more than half of journey is completed. That is the next question. The crystal structure of gamma iron. Now again, you can't be able to answer. No need to waste time. Be FCC. You could be able to answer. I know. So no need to waste time on that question. That is the next question. Gibbs phase rule. How we can relate the Gibbs phase rule? Question number 72. My dear friends, I am giving just 1 minute. Just give me 1 minute. 1 minute, no, 30 seconds. I am coming. राइट ओके बिल्कुल रॉयल तुमने बिल्कुल सही समझा है तुमने बिल्कुल सही समझा है हाँ यू गाइस आर रियल इंजीनियर सो व्हाट आंसर इज देयर क्वेश्चन नंबर 72 गिवन एवरीवन इतना कैसे तुम यार तेज हो हाँ yeah d for Delhi na good p plus f equal to c plus 2 right p plus f is equal to c plus 2 you used to say simple that is the question of thermodynamics could be also the percentage of carbon at eutectoid steel now tell me what will be answer of that question the percentage of carbon in eutectoid steel what will be answer of that carbon in eutectoid steel write down question number yaar question number 73 eutectoid eutectoid it talk about na so how much percent which is eutectoid point see iron carbon diagram where is my iron carbon diagram where was see here so baba this is called this point right this so how many percent 0.8 so what will be answer that's why I discussing 0.8 is the right answer d for Delhi not a for apple and other d for Delhi is the right answer 73 eutectoid पे पूछा जा रहा था that is the next question eutectoid reaction of iron carbon system occur at what temperature it is going to be occur eutectoid reaction iron carbon system occur 600 720 1490 1147 what will be answer of that question question number 74 answer everyone b 723 पे होता है जी 1147 डिग्री सेल्सियस चेन्नई 1147 डिग्री सेल्सियस अब याद करो सारी चीजें थ्योरी बताता हूं तो बोलते हो सर रहने दो this is peritectic reaction eutectic reaction here all we can say peritectic at 1442 degrees 2 degrees Celsius Austempering of steel result in greater austempering hardness toughness brittleness this is not a brightness or brittleness it should be brittleness ductility what will be answer 75 austempering of steel result in greater austempering hardness toughness brittleness or ductility what will be answer of that question my dear friends so I will this is the question has been from the heat treatment का austempering whenever you are going to do in the case of steel that depends upon the rate of coolings and this is going to enhance the toughness not the hardness austempering of steel result in the greater toughness okay so keep in mind toughness not the hardness here I have given so where we can say you can say austempering produce a bainite microstructure in steel compared to quench and tempered martensite steel bainite offer high toughness good ductility right okay that thing so that was the key benefit keep in mind the crystalline structure of aluminum yeah what will be the aluminum crystal structures anyone have remember if you have gone through my lectures I have given some technique also Rahul I am coming on the heat treatment question your dot itself will get cleared I will come on the heat treatment question your dot itself will get cleared just keep patience 10 to 15 minutes more Aluminium is what is aluminium babu this is called face centered cubic FCC aluminium is face centered cubic right so here we can see example of FCC aluminium copper nickel gamma iron gold silver BCC that a hexagonal closed pack if you have remember anyone I have given some shortcut किसी को याद है have you remember the shortcut that I have given है किसी को याद No one have remember? Don't worry. That technique will be very, very helpful. I will give, don't worry. Delta iron occur at the temperature. When delta iron is going to occur? I think you have did that question earlier. So no need to be again. Which of the following statement incorrect about the phase diagram? Which of the following statement about the phase diagram is incorrect? What will be answer? What will be answer? Question number 78 on your screen. See, which of the following statement about the phase diagram is incorrect? My dear friends, always keep in mind, rate of coolings is not going to be told by the phase diagram. I have time, temperature, transformation. Rate, I am going to be talk about time, temperature, transformation. Right? In iron carbide diagram, I am not going to be talk about the rate of cooling. I am just going to the percentage of carbon and the temperatures, not about the rate of coolings, right? So if you give through the option B, it gives information on the transformation rate. No, my dear friends, this thing is going to be given by the triple T diagram, time, temperature, transformation. Rest all are correct. So keep in mind. And that's why, my dear friends, if you talk about Martensite structure you will not find in the iron carbide diagram. Why? Because Martensite is depends upon the rate of cooling. So Martensite I will get in case of time, temperature, transformation. So sometimes even they are going to ask which of the following structures is not possible in iron carbide diagram, like that given. A Martensite will get on the time, temperature, transformation. Clear na? So yes, my dear friends, that is right. Na? D is right. Why you have given D? D is right. You are getting different textures at different temperatures. So it is right. You have to be get the incorrect. Clear na? So keep in mind. All are important at point. 78 you have did. Question number 79 on your screen. Question number 79 on your screen. On heating, one solid phase result into another solid phase and liquid phase during the reaction. Eutectoid, peritectic, eutectic, peritectoid. What will be answer of that question? Answer everyone. On heating, one solid phase result another solid phase and liquid phase. What I am going to be see? So 79. See my dear friends, always keep in mind. पी जाओ, इसको पी जाओ, पी जाना मतलब रिमेंबर, इसको याद रखो. सुनो, eutectic, at eutectic what is happening? One liquid converted into two solid. At eutectic, one liquid converted into two solid. At eutectoid, feeling ना eutectoid, क्या feeling आ रहा है? Something solid, eutectoid, id solid, solid. So eutectoid id solid, id. So feel आ रहा है solid वाली, something feeling like a solid. So we can say eutectoid id. So one solid converted into two solid, that reaction is called eutectoid. Clear? Eutectoid. Peri means more. अरे बोलते हो ना polythene. Peri means more. So peritectic. So what happening here? One liquid and one solid becomes another solid. Peritectic, something feeling liquid. Peritectic. Wide, id is solid, ek matlab liquid. Peritectoid. So eutectoid, u matlab one, so one solid converted into two solid, so it is eutectoid. In case of peritectoid, one solid, peritectoid means two solid going to be converted in the another solid, so this is called peritectoid. Peritectic, one liquid, another plus solid gives another solid. Eutectic, one liquid converted into two solid. So keep in mind that point and it will help you a lot in the exam. Right. Okay. How many space lattice does the Bravais lattice consist of? How many space lattice? This is the question from the crystal structures. What will be answer? Question number 80 on your screen. Question number 18. How many Bravais lattice? 14. Yes, it will be the 14. Keep in mind. It will be what, my dear friends? 14 is the right answer. So D for Delhi is the right answer, 14. Good. Every one of you have given the right answer that time. And keep your energy up, because tomorrow is your mock test that I will take here. We'll discuss all different variety of question from all the mechanical engineering, including engineering drawing and FEM. Well, so that is the next question. Eutectic product of in FEC system is called eutectic product, which is called eutectic product. And that's why I have dealing ना learning content. But आप लोग learning content देखना ही नहीं चाहते हो, तो फिर मुझे भी लगता है मैं क्यों टाइम बर्बाद करूं. हाँ, दिस इज ल्यूडिब्राइट यूटेक्टिक प्रोडक्ट Fe3C, उसको आप लिखा हुआ था ल्यूडिब्राइट. ये जो दैट पीडीएफ यू रीड ना, दैट इज व्हाट यू कैन से रामायण, जो भी तुम बोल सकते हो फॉर द इंजीनियर्स, स्पेशली फ्रॉम द आयरन कार्बन. नथिंग विल कम बियॉन्ड दैट, आई एम श्योर अबाउट दैट. सो एक बार पढ़ लेना दोस्त इसको, एवरीथिंग इज देयर. So B for Bombay is the right answer. 81 B for Bombay is the right answer. That is the next question. Question number 82 on your screen. What? When steel containing less than 0.85%, less than 0.85%, carbon is cooled slowly. Okay, sir, it is cooled slowly below the lower critical point. It contains what? Contains, see my dear friends, here see diagram. See 0.83 से कम. कम मतलब इधर, इधर क्या है? परलाइट प्लस फेराइट. अरे विजिबल, फेराइट परलाइट प्लस what? See 0.83 there and low temperature. So what? Ferrite plus what? You can say a perlite plus ferrite. So simply you could be able to answer. So what will be answer of that question? Answer that question. Question number 82 on your screen. Yes, B for Bombay is not right answer. C for Chennai is the right answer. Right now? Good. Remember, याद रखो सारी चीजें दोस्त, याद करो सारी चीजें. Do not forget, because after one day your exam is there, 2 days, huh? So one day will be in the journey. Which of the following line defect found in the metal crystal? You talk about line defect: grain boundary, crack, vacancy, or dislocation. Line defect, right? Which is called line defect, my dear friends? Which one is called line defect? See, the defect is basically 3 types: point defect, line defect, surface defect. Even volume defect is also casting, is comes under the category of volume defect, so that all are called defect. So when you talk about here, my dear friends, here see point defect, vacancy defect, interstitial, that all, Frankie, Schottky, that all are point defect. If you talk about surface defect, remember, yeah, that slide, remember all, even they are going to ask the name surface defect: grain boundary, twin boundary, tilt boundary, stacking fault, that all are surface defect. If you talk about line defect, edge dislocation, screw dislocation comes under the category of line defect. So keep name edge screw. Edge screw is a line. Even edge means line. Edge means line, na? Surface, grain boundary, twin boundary, tilt boundary, that all are. Point defect, vacancy. Point is, it is happening at a particular point. That's why it is called point defect. Vacancy, that all are. Frankel defect, ionic defect is comes under category of Frankel defect. Ionic defect is there. Fine. Martensite is a super saturated solution of carbon in alpha iron, gamma iron, beta iron, or delta iron. What you can answer that question? First of all, tell me, my dear friends, martensite from where you can get? Iron carbon or triple T? From where? Triple T, right? And martensite is a super saturated solution of carbon in, Babu, this is not the gamma iron, this is not the beta iron. Beta iron is not happening. It is wrong. It is actually not happening. Delta, it is coming under the alpha iron. My dear friends, listen. When the martensite will form, keep in mind, martensite will form now when you cool it in a very fast rate. What the meaning of very fast rate, sir? I am going to be cool it even earlier to the upper critical point. So that's why it is called martensite. And one thing I have told you earlier, my dear friends, if anything you are going to be cool at a very fast rate, it gives always brittle in the nature. It becomes hard. So Baba, keep in mind, martensite is highly brittle, highly hard in the structures, and it is going to be get in the time temperature transformation. And this is the solution of alpha iron. Keep in mind, right? So martensite is a very hard, very brittle. Why? Because it is going to be cool at a very faster rate, sir. And if anything going to be cool at a very high speed, it always gives brittle, brittle and brittle, hard, hard and hard. And one more thing, my students, I want to tell you, hard and brittle are brother. जहां भी hard जाएगा वहां brittle भी जाएगा. Both are twin. Whenever hardness increases, by default brittleness increases, right? Whenever brittleness increases, by default hardness is also increases. So these two are twin brothers. Whenever they one move, another will go automatically with them, right? So A for apple is the right answer. Keep in mind. Okay, Baba, for the next question. Okay, that is the next question. The predominant structure of hypoeutectoid steel has been quenched above upper critical. Now, just read the answer, Baba, of that question. अरे तुम फेराइट को ठंडा करो ना, फिर ना राहुल, कूल फेराइट एट ए वेरी फास्टर रेट. वो तो हमें ट्रिपल टी पे तो वही मिलेगा. तो फिर हमारे पास है, उसको कूल करो काफी फास्ट रेट में. The predominant structure, what will be answer of that question number? Yeah, that is martensite. Cool upper quench at above the upper critical temperature. This always gives the Baba martensite. What will be answer of that? Tell me. Martensite, Baba. This will be the martensite. Nothing else. Okay. Going to cool above critical temperature. It will be martensite. दिमाग में बैठा लो, आज बैठा लो चीज. और इंटरव्यू में फिर बात करते हैं. यहाँ पे भी मैं कुछ लिख के लाया हूं आपके लिए. ऑस्टेनाइट होगा, बहुत रैपिड कूलिंग से हमारे पास क्या बन जाएगा? मार्टेनसाइट बन जाएगा. फाइन. इन अ eutectic system, two elements are completely. What is happening here? What is happening here? Question number 86 on your screen. Question number 86 on your screen. Eutectic system, two elements are completely eutectic. You talk about what will be happening? Soluble in liquid, eutectic. So soluble in the liquid state. B for Bombay is the right answer. Soluble in liquid state. So B for Bombay is the right answer. Upper critical temperature for steel. What will be answer of that question? Question number 87 on your screen. Question number 87 on your screen. What will be upper critical temperature? Baba, read an answer. Is constant? No, sir. It is not constant, sir. Depends upon the rate of heating? No, sir. Critical temperature I get in the iron carbide. So in iron carbide, I don't talk about the rate, sir. So it cannot be, sir. Depends upon the rate of cooling. No, sir. I am not talk about rate of cooling and all that. So varies according to carbon of steel. Yes, C for Chennai is the right answer, my dear friends. And you have seen, as I have told you, this is in case of upper critical temperature, in case of hypoeutectoid, and this is in case of hypereutectoid. In both the case, we can say it depends upon the percentage of carbon. It depends upon the percentage of carbon, right? I'm going to meet all that. So what is happening? Okay. So C for Chennai is the right answer. Good. Question number 88 on your screen. Carbon occur in steel in the combined state with iron to form the component is called ferrite, cementite, perlite or bainite. Question number 88 on your screen. Carbon and steel combined state with iron to form. So it is become cementite, na? Huh? Fe3C, na? Fe3C. So it become what? Cementite. P for Bombay. Here we can see na cementite. हाँ, यहाँ पे देखो क्या है ये, यहाँ पे क्या है फुल Fe3C ना, सीमेंटाइट. This is the next question. The number of atoms per unit cell and the number of slip system respectively for the face centered cubic. Number of effective atoms per unit cell. How we can answer that question? Question number 89 on your screen. Just eliminate the option. You know, effective number of atoms is 4. How many effective number of atoms? How many effective number of atoms? In case of FCC, how many phase are there, Baba? Such we can say how many phase? 6 phase plus 1 corner. 6 phase में आधा आधा होगा तो 3 plus 1 4. Now we can go through, either answer will be C or D. B, A and B could not be. Okay, so if you talk about slip system, it is happening 12. So correct answer is what? C for Chennai is the right answer. C for Chennai is the right answer. है ना यार, फेस पे 6 होगा, मैं यहाँ पे दिखा भी देता, बट अभी चलो दिखा दूंगा फिर. Hypoeutectile still have carbon content. Hypoeutectile. Okay. Hypo it talk about na. Hypo, not hyper. Hypo. What will be answer? Question number 90 on your screen. Question number 90 on your screen. B for Bombay. Yeah. That time everyone have given right. Hyper it will be more. Hypo it will be less. So less than 0.83. So B for Bombay is the right answer. Good. थके नहीं हो ना यार, एक बात बताओ, अभी एनर्जी है ना? टेल मी, एनर्जी है या डेड स्टेट में हो? टेल मी फर्स्ट. अभी है तो मैं अभी और कराऊं अच्छा से, नहीं तो बोलो फास्ट कर दूं. डिपेंड्स ऑन यू गाइज. है अभी? मेरे पास तो बहुत है अभी. हाँ चले ना? चलो गुड. एनर्जी रखो. राइट, विदाउट एनर्जी नथिंग इज हैपनिंग. Yes. So B for Bombay is the right answer. That is the question number 91. Twin boundary are which type of crystal defect? Line, point, surface or none of the above? अरे मेरा तो था, आ गया था ये, पता नहीं ठंडा हो गया. तुम ही लोग लाइक करवा करवा के खूब बढ़ा देते हो. थैंक यू. कल मिलो फिर. सो नो 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 रियल यार, देखो जब कहीं पे भी किसी भी चीज की बात करो, जब प्यार मिलता है ना तो चीजें लगता है कि और अच्छा किया जाए, और अच्छा किया जाए. And if you see last 2 lectures that I have conducted, it goes more than 6K views. And if you talk about from the mechanical, only 12 to 13,000 students have filled the form, and in which half has already left the preparation. आधा तो पहले ही preparation छोड़ दिया होगा. And half of you and everyone is going to watch the lectures. It help us or motivate us lot of. It motivate us lot, and that's why I planned. Okay, tomorrow I will come again. We'll take all the mock test of the questions. Right? So, okay, come to that question. Question number 91. What you have given? Chennai, na surface defect, twin boundary. Twin what? Chennai, everyone? Good. Okay, so how many questions is left? Iron carbon equilibrium diagram indicate phase change occurring during the heating and cooling. Microstructure property of steel and cast iron, met floating carbon, percentage of temperature, all of the above. Yes, my dear friends, what could be answer? Question number 92. What will be answer? Question number 92. D. See, my dear friends. See, just read with option A. I'm telling you what you indicate phase change occurring during heating and cooling. A student will get confused. कि सर ने बोला था, sir have told that I am not talk about the rate. My dear friends, yes, in iron carbon diagram I not talk about the rate of cooling, but cooling and heating I talk ना यार. टेम्परेचर बढ़ा रहा हूँ ना, हीटिंग तो कर रहा हूँ ना, टेम्परेचर कम हो रहा है, कूल तो कर रहा हूँ ना, बट आई एम नॉट टॉकिंग अबाउट देयर रेट. सो फर्स्ट पॉइंट इज राइट. Indicate phase change occurring during heating and cooling. Yes, this is right. Second, correlate of microstructures and property of steel and cast iron. Yes, this is also right. Is made by floating carbon percentage and temperature. Yes, this also right. So what could be answer? D for Delhi is the right. Sometimes even in the offline class I used to see a student getting difficulty with option A. Baba, I do heating and cooling, but I am not talk about their rate. right? I'm not talking about their rate in the iron carbide diagram. So all are the correct, keep in mind. Okay, the question number 93 on your screen. The iron hatch. Yeah, I have taken that question intentionally, and I expect that you guys will make mistake in that. What will be answer? Question number 93 on your screen. What will be the answer? No, I know. अब लड़का सोच रहा है कि सर यहाँ पे आयरन दे दिया, they have given iron, sir, but I talk alpha iron, gamma iron, delta iron, but he talk about iron, sir. What I should consider, my dear friends, whenever in the question only iron is written, by default you talk about the room temperature, by default room temperature. So whenever iron, only iron, you have to be considered alpha iron, and you have to be answered according to alpha. Yeah, that's why I've taken that question, because I have seen in the offline class I used to see, once I give na, they used to say, okay, option is none of the above, let's assume option E is none, then a student is going to option none, and option E is think no one. But if whenever they given iron, by default you have to assume it is at a room temperature, and room temperature is what? BCC. So don't make a mistake like that. So B for Bombay is the great answer, right answer. Okay, question number 94, and yeah, I'm coming close to 100. Answer that question. Question number 94 on your screen. Question number 94, Baba. Iron carbon usually 1.72 is called hypoeutectoid or hypo or hyper eutectoid, hyper eutectoid cast iron, hypoeutectoid, hypo. So 4 point more than 4.3 it becomes hyper cast iron. Okay, I am coming question diagram here. Yeah, see there, after that na, this point 4 से ज्यादा जाएगा तो hyper हो जाएगा, hyper cast iron, right? Hyper. So but it is less, so it will be hypoeutectoid cast iron, this time not steel, cast iron. And yeah, good thing is that right. So C for Chennai, right? Right answer, good. Okay, so good. That is the question number 95 on your screen. And eutectoid still consists of what? The eutectoid still consists. Answer everyone. When you order paneer and chef comes with कढ़ाई मलाई बटर सारा लेके आ जाता है, ऐसा होता है? और पूछता है जी कि बताओ कौन सा पनीर चाहिए तुम्हें, हाँ? नहीं तो बाय डिफॉल्ट मटर पनीर समझ लेता है वो. And eutectoid still consists whole perlite, whole austenite, ferrite, still consist. And eutectoid. What will be answer? Yeah. 95A4. Yes. Pure iron of the structure. Now I think pure iron, ferrite, perlite, austenite. What will be pure iron? Pure iron will be what, my dear friends? I think everyone can answer A. Now, pure iron is what? Ferrite. Alpha. You can say alpha ferrite or ferrite, whatever. So A for apple is the right answer. Good. Everyone have given? Chandni. Well, you guys have huge patience, huh? Really. All the students who have attended the class, really you have good patience. And it will give result, don't worry, huh? Next, this is give the difference between graphite and the diamond. क्या है दोनों के बीच का difference? The difference between graphite and the diamond is that tomorrow मैं बता रहा हूँ नेट बचा के रखना. I have 100 question, but I will take approximate 4-hour class, and it could be more than 4 hours, right? So save your net for tomorrow, because I will discuss all the things, all subject, all concept. So it will take 4 or more than 4-hour class. Only question is 100, but yeah, different, all the different varieties, things I have to discuss there. What question number? Diamond is transparent while graphite is opaque. That is right. Difference between, okay, that is right. Diamond is insulator while graphite is conductor. That is also right, Baba. Diamond insulator hota hai, graphite, yes, could be. Diamond have primary bond and graphite have 3 primary and 1 secondary. All are the correct answer. Keep in mind, and even they ask one of the option. So all are the correct answer. So 97, D for Delhi is the right answer. What about Griffin? Sometimes एक बार ये पूछा हुआ है Griffin क्या है? नहीं, Rahul, no यार. What? Diamond is good conductor of what? You can say the diamond have good thermal conductivity. In fact, highest thermal conductivity in all the metals. 2300 watt per meter Kelvin. Diamond have highest thermal conductivity, right? In case of metal, if you talk about, silver have highest thermal conductivity. What answer? What you have given here? Heat. So question number 98 on your screen. Yes, A for apple is the right answer. Keep in mind, Baba, about the Griffin. A for apple is the right answer. Right now? So A for apple is the right answer. Good. 98 you have given. Question number 99. Out mat ho jana. Question number 99. Peritectoid reaction is. What is peritectoid reaction? What will be peritectoid reaction? Anybody can tell me? Peritectoid reaction is. Peritectoid. The question is peritectoid. Peritectoid. Toid means solid. Peri matlab more. Right. Peritectoid. How you are going to give the answer about the liquid, Baba? Peritectoid. OID, ID, solid वाला फील नहीं आ रहा है. हाँ, आइड वाला सॉलिड वाला फीलिंग नहीं आ रहा है. पेरीटेक्टोइड, आईडी, सॉलिड, सॉलिड में भी आईडी, राइट. सो डी फॉर दिल्ली इज द राइट आंसर भाई. राइट, डी फॉर दिल्ली इज द राइट आंसर. गुड. पेरी ज्यादा सॉलिड मिलके एक सॉलिड देना, पेरीटेक्टोइड यू कैन से. नेक्स्ट. Okay, that is the question number 100 on your screen, and hopefully that this time everyone can give the right answer. Can I hope? हाँ जी, कर तो सकता हूं आपसे. चलो बताओ. Consider the following statement about the edge dislocation in the crystal structure. Edge dislocation. पटेल, ये तुम बोल क्या रहे हो? पहले मुझे पूछ रहे हो या कुछ मतलब सजेस्ट कर रहे हो या कुछ अप्रिशिएट कर रहे हो? पहले ये क्लियर करो. हाँ, कंसीडर फॉलोइंग स्टेटमेंट अबाउट द एज डिसलोकेशन इन द क्रिस्टल स्ट्रक्चर. क्या होगा दोस्त? क्वेश्चन नंबर 100 ऑन योर स्क्रीन. इसके बाद हमारे पास 31 क्वेश्चन और है. 31st क्वेश्चन यू हैव आफ्टर दैट. यस माय डियर फ्रेंड्स, ग्रेट. गुड थिंग इज दैट गुड न्यूज इज कमिंग. All of you guys have going to give the right answer. Always keep in mind, edge dislocation in the crystal structure, Berger vector is perpendicular to the dislocation line. If you talk about the edge dislocation, so Berger vector is perpendicular to dislocation line. A for apple is the right answer, Baba. A for apple is the right answer. Right. Keep in mind all that. Berger vector is perpendicular to the dislocation line in case of edge dislocation. Another could be there also. And here Berger vector is parallel to the dischloride in screw dislocation. So these two are very very important, my dear friends. In the question this is going to ask, in case of Berger vector perpendicular to the dislocation line, or Berger vector in case of edge dislocation, in case of screw dislocation it will be parallel. So इसको दिमाग में आज बैठा लो, एग्जाम में आएगा. अगर edge dislocation आएगा तो perpendicular होगा Berger vector, and if you talk about screw dislocation it will be parallel. Right. So question number 101 on your screen. Screw dislocation in the material is line, point, plane or volumetric. Which type of defect is there about the screw dislocation? A screw dislocation in material is a, what will be? Line, point, plane और volumetric. Casting वास्टिंग volumetric होता है दोस्त. Casting, welding इस सबको हम volumetric बोलते हैं. Yes, screw dislocation Each comes under the category of line defect. And yeah, good thing is that all of you have given the correct answer. Okay, so my dear friends, that is the next question on your screen. Which of the following is correct for the Berger factor in screw dislocation? In screw dislocation, this time is going to be asked. Screw dislocation. Answer everyone fast. Yeah, yes, right. That time, अगर ये edge dislocation होता, then it will be answer A. But since screw dislocation, so C for Chennai parallel to the dislocation line is the right answer. C for Chennai, yaar. Why B for Mumbai? Who have given? Gagan, B for Bombay, no, yaar. C for Chennai, okay? Question number 103 on your screen. Following structure are arranged in the order of decreasing hardness. Well, decreasing hardness. How you are going to arrange them in the decreasing hardness? Decreasing. Remove the option. You can say, sir, removing option. D cannot be, sir. Rest I all think. I am going to remove, but D is not sure. So decreasing order, na Baba. Keep in mind, I want to tell you one thing. Decreasing order, whenever you talk about the highest hardness you can get in the martensite, which all air. After martensite, one phase is coming. Before that, this is called torosite or trusite, whatever you have to pronounce. After that, bainite, and after that, sorbite. So my dear friends, keep in mind, at least till the exam, B for Bombay is the right answer. Before the martensite, you will get that things is coming out to be during the rate of coolings. So that is the order. A is the right answer, nothing else. So keep in mind martensite, trusite, bainite, and sorbite. So A for apple is the right answer. Martensite, hardened structure in the steel, tempered martensite, bainite, intermediate martensite, and so okay, tempered. What is tempering? I will tell you. Give me 5 minutes. I will come. What is tempering? After 5 minutes, I will come. So martensite, this is hardest structure. Torosite, when do the when I am going to do tempering in the martensite, then I got a trosite. Bainite is one of the intermediate hardness, and sorbite more heavily tempered and softest among these. In all of that, this is सबसे softest है. How I can remember, sir? In the exam, they will ask how I can remember. S for sorbite, S for softest. मैच कर रहा है कोच. हाँ सर, कर दो रहा है. टेक्निक तो आ रहा है कुछ कुछ. हाँ तो टेक्निक ही याद रखना अपने को. राइट. दे में आस्क व्हिच ऑफ द फॉलोइंग इज द सॉफ्टेस्ट. इट विल बी क्या हो जाएगा बताओ? सोरोबाइट. याद है रहेगा? इस सब में, इस चारों में कौन सबसे ज्यादा सॉफ्ट है? एसओ में सोरोबाइट आता है. राइट. टेक्निक सही लगा जी कि नहीं लगता है? बताओ यार. पूरा कुछ नहीं, टेक्निक भी बताता हूं ऊपर से याद रखने का, फिर भी आप लोग कोई बात नहीं दोस्त. दैट इज द नेक्स्ट क्वेश्चन ऑन योर स्क्रीन. क्वेश्चन नंबर 104. Question number 104. The phase that not appear in iron carbon equilibrium phase, and you have to answer. Austenite, cementite, ferrite and martensite. और ये क्वेश्चन का जवाब जो नहीं दोगे वो मिरर के पास जाओगे और फिर रोते हुए भगवान से क्या बोलोगे? हे भगवान, मैं ही ऐसा क्यों हूं? दुनिया में आपने इतना को बनाया, मुझे ही ऐसा क्यों बनाया? राइट. Yes, my dear friends. Correct answer D for Delhi martensite. Good. So दिल बहुत दे रहे हो आप लोग. गुड. लाल हो जाता है कमेंट बॉक्स. यू आर नॉट अपियर. चलो बहुत बार पढ़ चुके. नेक्स्ट example of metal that crystallize in BCC, FCC, close. Okay, even easily you could be able to answer that question also. Right. इसका भी आंसर आप लोग दे सकते हो. इतना तो बता सकता हूँ यार, इतना पढ़ाया हूँ, इतना तो आंसर दे ही सकते हो ना, कि नहीं दे सकते हो? Question number 105 on your screen. Answer everyone. 105 D4. देखो BCC, yes, अल्फा आयरन, FCC गामा आयरन, हाँ गामा आयरन, BCC FCC क्लोज अल्फा गामा, या राइट आंसर. What you have given all guys? D for Delhi, na? Everyone have given D for Delhi. If everyone have given, then how can I say it is wrong? क्योंकि हमारे देश में डेमोक्रेसी है, जो सब कहेगा वही होगा. So D for Delhi is the right answer. Fine. Okay, answer that question. In the starting of the session, I have told try to remember that value, and I am damn sure you have not remember. Answer that question. The nearest distance between the two Nijorbor atoms in case of body-centered cubic structures. How we can relate? Actually, R they talk about R and A relations. You talk about what will be answer of that question? Babu, you guys are making mistakes. It will be A. Huh? Here I have told you na. BCC R equal to root 3 A by 4 na. A. Please remember A R relation na. Remember. They are going to ask my dear friends. Huh? In case of simple cubic A equal to 2R, hexagonal A equal to 2R like that. Okay. So remember that here. FCC also remember. Okay. So that closed pack is found in closed pack hexagonal. Okay. Now option, eliminate the option and go through and answer that. Closed pack hexagonal. HCP hexagonal closed pack. Where you can find? See, alpha iron. No sir. Alpha iron cannot be sir. Gamma iron. No sir. Gamma iron have FCC no sir. So sir it cannot be sir. None of these. No, I go through the option C. Zinc, magnesium, cobalt, cadmium, antimony, bismuth. Yes. I want to tell one shortcut for the hexagonal closed pack. Hexagonal closed. That's in Hindi. Kobako, ko, ba, kobako, mata, jinga jinga. ZING, jing, jing. That is the way. Kobako, mata, jinga jing. Cobalt, okay, beryllium, here इसके बाद something cobalt, cadmium, कोबाको, कोबाका, Ca, Ma से TA से titanium, Ma magnesium, yeah, Ma magnesium, potassium is not there, zinc and zinchronium, right? I have tell all that approach in the class. One is what? तू चल भाग फेंकू मारेगा, right? एक is what? Go and go plassi and nikal cup. So in that way all you could be able to remember. So here kobaka, mata, jinga jing, like that I have just filmed, and that is my patented. Okay, used to say. इससे क्या होता है, याद हो जाता है आपको. Oh, question number 108 on the or your screen. Which of the following region of the electromagnetic spectrum would be used to determine the structure of crystalline solid? What technique you are going to use? Microwave, infra, X-ray or visible? Question number 108 on your screen. What will be answer? 108. X-ray na? X-ray, right. C for Chennai is the right answer. This is the next question. Usually material with the following crystal structure fail in ductile mode. किसको मैं ductile बोलता हूँ? FCC, BCC, ductile में कौन आ जाएगा? FCC, BCC, all that, none of these. FCC ना? Good. That time everyone have given face centered cubic. Here I have given something, you can just read here. See, BCC, FCC, FCC strong in brittle material, BCC strong in ductile, right? Weak in ductile material, all that. Relative amount of phase in a region can be calculated using phase rule, Revel rule, either A and B or none of these. Relative amount of phase in a region can be calculated by using what? You can use for that. Question number 110 on your screen. Question number 110 on your screen. What you can say? Yeah, I know. What DBT you talk? Answer is what? Lever rule, not phase rule, nothing like that. Okay, you are going to use the lever rule just to make you confused. It is given either A and B. Phase rule what? Different types of rule is there. So actually you are going to find the lever rule. It is something like that. Here lever is there, on that you are going to be answer. So B for Bombay is the right answer. Which stainless steel is used in cryogenic vessel? Which stainless steel is used in the cryogenic? Cryogenic, you know, thing you have to operate at a very low temperature. Now, which stainless steel is used in cryogenic vessel? Ferrite, austenite, martensite, or none of the above? What do you think? Question number 111. Austenitic, right? Always no, not ferrite. Ferrite will be very soft. You are going to use the austenitic. B for Bombay is the right answer. Cryogenic vessel, you are going to use the austenitic steel. So that is the question. Pure graphite contains what? The I think that everyone can answer. Na? What the mean by pure graphite? Pure graphite contain. I think all can answer that question. I am damn sure यार. इतना तो भरोसा कर सकता हूँ आपके ऊपर कि इतना ना करूँ. यस सर, इतना तो करो सर, हक बनता है. 100% प्योर ग्रेफाइट है ना, यहाँ पर 100% क्या हो जाएगा बताओ? कार्बन हो जाएगा दोस्त. बिल्कुल सही जवाब है. The lower critical temperature, I think that question again all of you can answer. That question again you all can answer. Lower critical temperature. What is happening about the lower critical temperature? Answered everyone? That time you guys have given the right answer. पकड़ लियो ना concept. Good. पकड़ लियो concept now. Decrease as the carbon can no sir. Increase no sir. It is same for all the steel. It is same for all the steel. So C for Chennai is the. अब ये हैंग कर गया, मुझे 1 मिनट दो, मुझे लगता है अब इसको ना बंद करके करना पड़ेगा फिर से. अब ये लो, ओए कटना पड़ेगा, लैपटॉप से ही कटना पड़ेगा, फिर तो यार स्टूडेंट नहीं होगा. Just give 1 minute. सत्यम तुम ही आ जाओ यार, तुम ही डालो, मेरे से नहीं होता है. हाँ, right. So C for Chennai is the right answer. This is the next question. Okay, now I am going to be take here. Heat treatment. So whatever next question I have, this is from the heat treatment and quenching, annealing, tempering. Whatever doubt you have, you can able to solve the question from that segment, and that type of what is tempering, annealing, all that doubt will be cleared. Okay, Rahul. प्रोजेक्टर का भी हीट ट्रीटमेंट करता हूं, पुराना बोर्ड है थोड़ा, बट या फाइन, इट्स गुड. So that is the first question on your screen from the heat treatment, most important topic. We will find a question from that segment also. So that is the first question on your screen from the heat treatment. The question is that quenching is not necessary when hardening is done. Case hardening, flame hardening, nitriding, any of the above. So quenching क्या है दोस्त? सुनो बात. What do you mean by quenching? देखो, जब किसी चीज को you have a steel or anything, obviously I am talking about steel here because in heat treatment mostly I talk about the steel only. So suppose you have a steel and you are going to be cooled it at a very high rate, like you are going to be you have a steel, it is a very high temperature, put in the water, you can say it is a quench, right? So quenching means simply you are going to be cooling rate is very faster, that is the meaning of quenching. Sometimes put in the oil, so that is the meaning of quenching. बताओ ठीक है. So quenching is not necessary whenever you talk about which, my dear friends, what answer you are given? So nitriding. Okay, if you talk about option C is what, my dear friends? I will discuss about all that. Whenever quenching is not necessary when hardening is done by nitriding, when you are going to do the How many approach to increase the hardness? Hardness you can increase by simply we can say the carburizing, by nitriding, by cyaniding, by all that you can increase the hardness. क्या 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 बताओ? Carburizing, nitriding, cyaniding. In all of these, which gives the highest hardness? Always keep in mind, nitriding gives the highest hardness of the surface, right? Surface. So always keep in mind, quenching is not necessary and hardening is done by nitriding. So they see here nitriding is surface hardening process carried out at a relatively low temperature when nitrogen diffuse into the steel and forms hard nitride. As I told you, na, this is the gap. Earlier I used to put the carbon. Now instead of carbon, I am going to put the nitrogen. Nitrogen here. So nitrogen little bit more in the size with respect to carbon. So a strong little bit become more stronger, and it becomes more. You can say the hard surface, right? So it does not require quenching after heat treatment. It does not require any types of quench. You don't have to be sudden, cooled to get the hard surface. No. Case hardening, surface hardening process. So all I have written here, every all point, all that key flame hardening, all I have written here. Okay, key important, all that. That is the next question. Machine tool guide, which are generally hardened by. Machine tool guide generally hardened by. By which process it is going to be hardened? Question number 115 on your screen, my dear friends. Now only 16 questions is left. Now only 16 questions is left, my dear friends. So keep it up, be energetic. You have done that. So machine tool guide generally hardened by, it is going to be hardened by Baba flame hardening. ठीक है? Induction hardening, vacuum hardening नहीं, mild tempering नहीं. This is going to be done by the flame hardening. Right? What? 115 will be the answer, flame hardening. Here I have written, see, machine tool guide we generally hardened by the flame hardening. Flame hardening is a common surface hardening. This is a surface hardening method. Metal surface such as steel are heated with a high temperature flame and then quench. You see, in the flame hardening, what you are going to do? You are going to be quench. Quench means fast rate of cooling. Quenching matlab, what the mean of quench? It is a fast rate of cooling, right? So what you are to do? Surface hardening, basically nitriding, cyaniding, flame hardening, that all are surface hardening, means resistance against the scratch. Quench, the result of the flame hardening is hard surface and that more resistant against the wear and the corrosion. So this is called flame hardening. So simply they may ask what is flame hardening? Surface hardening in which metal surface such as steel are heated with high temperature flame, then quench, fast cooling, then we'll get. Right? Next question. Nitriding process used to increase the surface hardness of cast iron, alloy steel, high carbon steel, or none of the above. Nitriding process. What you can use, my dear friends? Nitriding. Nitriding. What you can use nitriding? Everyone answer. Nitriding. Babu, think about. If you go through cast iron, sir, in case of cast iron, already percentage of carbon is high. So already it is hard. If I talk about high carbon steel, na sir, so in case of high carbon steel, already carbon is high. If the carbon is high, sir, already it is hard. So इसको मैं क्या hard करूं सर? Already ये hard है. हाँ, तो सर क्या करूं? किसको? एलवाई स्टील को. या एलवाई स्टील में क्या होगा? कार्बन आयरन के छोड़ के और भी तीसरा कंस्टिट्यूएंट्स होगा. So that is called alloy steel other than carbon iron. Right. So correct answer will be B for Bombay. Who's Sarma ji? All are good questions. Are you believing or not? Tell me first. Whatever question you are saying, all are really excellent question and you find in the exams. Go and sit in the exam, then we'll feel in exam. Okay, Rajiv sir is telling in YouTube session. Remember. But मेरे कान पे जू तक नहीं रहेगा था. So I am finding difficulties, right? Well, so ऐसे सोचो यार. Already it is hard. Why need to hard? Right? Yeah. Suppose I am telling you option B is mild steel. Yes. Then I will go through the mild steel. Now suppose option B is mild steel. Yes, sir. Then I can go with the mild steel. Why? In the mild steel, percentage of carbon less, na sir. Percentage of carbon less means it is a not hard, na sir. So need to hard. I will use that. Right? 116 question number 117 on your screen. 3 घंटा 5 minutes. Okay, already okay. I have target, but tomorrow class will be the 4 hours, so be ready for that. To reduce brittleness of the hardened steel and thus to increase the ductility and to make the steel sufficiently tough to resist the shock and fatigue, which heat treatment process is used? Nitrating, tempering, normalizing and hardening. What will be answer at that question? Question number 117 on your screen. कितना का नेट समाप्त हो गया है? ड्राइवर कौन है ये भी देखो शर्मा जी. हाँ, who is driver? See what answer I am getting? Yes, my dear friends. See, to reduce the brittleness. See what is happening generally now. Generally, as I told you, listen. What I have told you, my dear friends. Generally, brittleness and hardness are twin brothers. Generally, brittleness and hardness are twin brothers. Whenever hardness goes, साथ में brittleness भी चला जाएगा. Now see, you need hard but not brittle. I require that type of material which is hard but not brittle. So what I have to do, sir? Because whenever hardness brittle is happening, yes, my dear friends, to get hard but not brittle, I am going to do the tempering process, Rahul. What? I am going to do the tempering. Because as I told, if I go nitrating, sanding, hardening, that all enhance the brittleness. Okay, but I don't need brittleness, na. I need hard but not brittle. That's why I do the tempering. How tempering happening, sir? That is a good question. See, my dear friends, after hardening, steel becomes very hard and also brittle. So tempering is done. Reduce brittleness, increase ductility and toughness, improve resistance to shock and fatigue. What is tempering? Tempering means reheating hardened steel to temperature below its critical point, Babu. In all the exam, in all the interview, they are going to ask what is tempering, where you have to be heat. So it will be below its critical point, then holding it there for some time and cooling it usually in the air. हम हवा में ठंडा करेंगे, धीरे धीरे ठंडा होगा, slowly it will cool, not in the water, right? Not in the water. So that is called tempering. Slowly cool कर रहे हैं हम, ductility हमारा बढ़ेगा, all that. Fine ना? So after hardening steel very hard and very after hardening बहुत hard हो जाता है. So tempering is done. Why? Reduce brittleness, ductility, increase ductility, improve resistance shock. Clear to know? Tell me, is it clear to everyone how the tempering is done? Yes, I am going to be cool below the critical temperature, hold it for some time, then allow to cool in the air. Since cooling rate is slow, sir, and from the very earlier I used to say, if the cooling rate is slow, the result will be always ductile, right? Okay, yeah, that is the next question. Heat treatment given to harden steel to improve its ductility. Good call. Annealing, normalizing, tempering, and hardening. What will be the answer of that question? Question number 118 on your screen. Question number 118 on your screen. Annealing, normalizing, tempering. मेरे देशवासियों, मेरे प्यारे देशवासियों, you guys are going to give the wrong answer. अभी मैंने एनेलिंग पढ़ाया भी नहीं. Heat treatment hardened steel to improve its ductility. I am go to the tempering. If you go through annealing and tempering, लगभग दोनों में काम एक ही है, but in the annealing little bit less ductility we can get. Why, sir? Why, sir? Why? Okay, I am telling you here. See, tempering, okay, improve ductility, toughness. In case of annealing, na fast, cooling rate is little bit faster. In case of annealing, you take a talk later. I will see, Babu. I will see. Don't worry. If you talk about tempering, in tempering, what is happening? Cooling in the air takes place. So very slow rate of cooling. But in the annealing, cooling will be little bit faster. Could be, right? So we can get that thing. Heat treatment gives the hardened steel improve the ductility. I think we'll come on that question once again. Don't worry. Okay, recurrent temperature of the pure metal in TM is, what will be answer of that question? In case of pure metal, just now you have seen. I think now everyone can answer that question. 119. Question number 119. 0.3, that option are very close now. They should not give such a high close option. Even 3 of C or D both could be answer. Okay, I will go with the C, but that not should be such a more closed. Next question. Annealing of white cast iron produce grey cast iron, nodular iron, malleable iron, wrought iron. Annealing of white cast iron produce what? Question number 120. 120. Question number 120 over your screen. What will be answer? Chennai. Malleable. Annealing of white cast iron always gives the malleable iron. What cast iron gives the malleable iron? Malleable. So C for Chennai is the right answer. Question number 121 on your screen. The process of reheating of a martensite steel to reduce its brittleness without any significant loss in its hardness is called. Rahul, your question is came here, I think. Question number 121 on your screen. Question number 121. The process of reheating material steel to reduce its brittleness without any significant loss its hardness. What will be? What will be answer? Tempering, right? That time you have given what? Tempering. See, my dear friends. Okay, now I am going to define all that. Now I am going to define all that. See, all I am going to define here. Now, see, my dear friends, here. Martensite steel is very hard but highly brittle. The process of reheating martensite steel to a temperature below the critical temperature in order to reduce brittleness without much loss of hardness is called tempering. Now, what about normalizing? Sir, in heat treatment process in which steel is heated above the critical temperature and then cooled in steel air to refine grain structure and improve strength and toughness, this is called normalizing. This is called Austempering. I will come. Ayush, one question I have, don't worry. So heat, okay, what key point you have to be keep in mind? In case of normalizing, heating is done at above the critical temperature and then cooled in air. But in case of tempering, lower the critical temperature, going to cool in the air. लोअर क्रिटिकल टेम्परेचर हम कम पे ठंडा करते थे, कूल करते थे एयर में. यहाँ पे नॉर्मलाइजिंग में हम क्या करेंगे? above the lower critical temperature हम हीट करेंगे and cool in the further in the air. So it improves the strength and also toughness little bit. The ductility also increases. Now, annealing, a heat treatment process in which metal is heated above the critical temperature, hold there and slowly cool, usually in the furnace to make soft, ductile and stress free. Here cooling is very low, even we can say going to cool in the furnace. Furnace means higher temperature पे हम cool करता हूँ. देखो, see, Q is directly proportional to delta T ना दोस्त. Q is directly proportional to delta T ना. Delta T is what? Surface temperature minus of you can say the surface temperature minus of ambient temperature. If surface temperature is high, ambient temperature is less, so heat transfer rate will be fast. But my dear friends, just think, if ambient temperature is also high, so what will be heat heat transfer rate? Less. Here will be ambient temperature high in furnace. In furnace, this difference will be less, heat transfer will be the less, right? So that is called annealing, makes stress free all that. Quenching, rapid cooling process, just put in the water, oil or brine solution, carried out after the heating, still above critical temperature to increase the hardness by forming martensite. So quenching is the process by which you can get the martensite structures, right? So keep in mind all that point, my dear friends. I will share that PDF, don't worry. That is the next question on a screen. Which medium used for fastest cooling during the quenching of a steel? What will be? Air, water, brine solution and all that. 112 on your screen. Water, brine solution and all that. My dear friends, see, this will be the brine solution. Water mein na, brine solution will be the right answer. Otherwise, I can go through the answer. Water also, but since brine better they have, so D is the right. Otherwise, C is not problem. Right? नमक पानी ठीक है, चलेगा. अगर नमक पानी नहीं होता, brine water, then we can go through with the Chennai. So that like way you have to be think and answer. बढ़ जाएगा, बढ़ जाएगा, बढ़ जाएगा, बट काफी और भी चीजें इंप्रूव कर जाएगा. सत्यम और भी चीज इंप्रूव करेगा along with ductility. little bit they can change the, I am telling you, in the annealing they can change the hardness also. Satyam, they can change the hardness, but tempering not going to be change the hardness, right? It going to reduce the brittleness, increase the ductility. Annealing, hardness can also affect. Fine. So that is the next question. Case hardening in only method suitable for hardening. Case hardening, what do you mean by case, Baba? What do you mean by case? Case means surface, right? Case means surface hardening. Case means surface hardening. Whenever you talk about case hardening, means you have to be surface hardening. Surface hardening means resistance against the scratch will be good. So question 1, 2, 3 on your screen. Case hardening is only method suitable for hardening high alloy steel. My Baba, dost, use your common sense. Sir, high alloy steel. Sir, high alloy steel, I think it is already hard, sir. High speed steel, already hard, sir. High carbon, ha, sir. Low carbon steel, na, sir. So in case of low carbon steel, hardness is less, so I will prefer. And इसी देखो सोच के आंसर दियो, कितना सही आंसर दियो, क्या रटना है इसमें? No need to buy hurt anything. So that's why from the very earlier class I used to say in the class, rather than by hurting, go and work on the basic. Once you work on the basics, everything looks like easy. But you guys never trust over your educator. Huh? That is the bad thing. You should do. Right, my dear friends. Okay, so only few questions is left. That is the question number 124 on your screen. Question number 124. Answer that question. What? The aim of tempering heat treatment is to reduce, I think very easy question, yeah. You guys can do that. 1 to 4 on your screen. 1 to 4 on your screen. Reduce. What answer? Huh, yeah. What answer? B. What answer you think about? The aim of tempering heat treatment is to reduce hardness while sustainable, reducing brittleness. No, it should be it should be opposite, right? They have typed wrong. Don't, okay, B, but it should be opposite. Huh? Then it will be. Okay, this in Austempering process, who was asking of heat treatment, the austenite change into in Austempering process, the heat treatment, the austenite changes to. Question number 125 on your screen. Question number 125 on your screen. The Austempering, yeah, just now earlier I have discussed about that. Na, yaar. This will be Bainite, okay? Austempering process heat treatment. Sorry, austenite changes to Bainite. I have written there. Okay, I have written here, na? Steel heated from austenite, then the quench to a temperature above the martensitic style. Okay. अब दो एक बार मैं फिर से इसको क्या करूं, कल तो 4 घंटा क्लास है यार, अगर ये मेरा बोर्ड ऐसे करेगा तो कैसे काम चलेगा? थिंग इज हैंग्ड. जस्ट गिव 1 more minute. ओके यार, ये क्या हो गया, काम ही नहीं कर रहा है. right? Chalo, good. One answer you have did. So that is the next question. तुम्हारा क्यों नहीं होगा भाई? हाँ, किसी का होना है, खुद का क्यों नहीं होना है? Very high, very low confidence रखे हो. Austempering employed to obtain. Why you are going to be 100% B for Bombay? Everyone, na? What will be? Aust employed for get 100% is which structure? Bainite structure? Yes. So 100%. Now it's not working. Okay. 100% Bainite we can get. So B for Bombay is the right answer. B for Bombay is the right answer. Good. 100% Bainite we can get. Good. Question number 127 on your screen. Yeah, time temperature transformation diagram indicate time and temperature transformation of cementite, perlite, ferrite, austenite, none of the above. 127 on your screen. Time temperature transformation. What will be answer? 127. What about others? D for Delhi. Yes, my dear friend. Just now you have seen na austenite. So D for Delhi is the right answer. Good. अब देखो आपका पूरा रिवाइज हो चुका है, पीडीएफ देख लो. आई एम टेलिंग यू नथिंग इज गोइंग टू आस्क बियॉन्ड दैट. Why? Because as I told you, I have discussed all the different types of things, right? So be assured about that. But try to remember that thing in the exam. ऐसा ना हो कि भूल जाना. Hardening of steel does not increase its hardening of steel, resistance, corrosion resistance, tensile strength, or hardness. What will be question number 128 on your screen? Question number 128 on your screen. Hardening of steel, which thing is not going to be changed? Answer everyone. See my difference. Hardening, basically they don't have to do anything with the corrosion resistance, right? You have to use the chromium only. So hardening is not going to be anything going to be changed about the corrosion. Tensile strength they can change, na, because brittleness, all that thing is happening. Hardness, obviously, residual internationalness can change, but they are not going to do anything with the corrosion resistance. So कभी मैं hardness बढ़ाता हूँ तो उससे हमारा corrosion resistance पे nothing going to be change, उस पर कोई फर्क नहीं पड़ेगा, right? So B for Bombay, not others. In tensile strength will get changed little bit, all that will change. Well, my dear friends, that is the question number 129 and third last question of today. The effect of strain hardening are removed by effect of strain hardening is removed by tempering, annealing, normalizing, or aspirantizing. Effect of strain hardening. What is happening in the strain hardening? Effect of strain hardening, Baba. Strain hardening means cold working, right? Strain hardening means cold working. And in the cold working, Baba, what is happening? Tell me. Always internal stress lift. जब cold working करते हो तो क्या करते हो? Going to heat. After that, you are going to be hammered. And due to that hammering, internal stress lifts. Internal stress generate. And tempering is not going to do anything with the internal stress. That is annealing, Baba. Annealing. पहले से बता रहा हूं. If you talk about strain hardening is a cold working. In cold working, what is happening? I am going to heat the material below the leak crystallization temperature, and after that I am going to hammer over that, and due to the hammering and all that action, the internal stress generate, and that is not good. So to relieve that internal stress, Baba, I am going to do the annealing. What a simple, what a simple things is there. So annealing will be there, not tempering, right? Clear to everyone? Tell me, Baba, clear or not? Alright, tell me, clear or not? Right. So answer will be B for Mumbai is the right answer, Rahul. In that you have to be think. So that is the second last question of today, and after that we'll meet tomorrow. Wow. Objective of tempering. Now I think everyone can answer that question. What is the objective of tempering? What is the objective of tempering? Improve ductility, reduce ductility, improve brittleness, improve internal stresses. Sir, ductility, simple, sir. A for apple. Improve internal stresses? No. This is done by the annealing. Right, Baba? So, yeah, Now I can say you guys are full trained to solve all different variety of material science question, and that will be the last question of today. And after that, we'll meet tomorrow with 100. Okay, that is last or second last? How many question left? I think 2-3 question further left. Okay. Okay, 132. How many question is there? Yeah, even I forget. 133. Okay. How much question I have taken? What? 134 is also there. 135 is also there. Okay, 135 question. Okay, 136. Very question, yeah. Okay, that is 136 question was total. Right. So, कितना पे हम लोग हैं जी? 130. Okay, 6 question is left. No problem. बट एक चीज तो है भाई, बहुत पढ़ लियो आप, उससे बाहर नहीं आएगा क्वेश्चन। अगर इतना आपने याद कर लिया ना लास्ट में, नथिंग इज गोइंग टू आस्क बियॉन्ड दैट। एक दो आएगा, देखो समटाइम्स इट इज सेड दैट इवन इफ यू आर सिटिंग ओवर द एलिफेंट स्टिल डॉग कैन बाइट यू। भाग जब खराब होता है ना, तो हाथी पे भी बैठा रहोगे तो कुत्ता काट सकता है। तो अगर आपका भाग खराब है तभी हो सकता है यहां से बाहर है। अगर लिटिल बिट भाग इन योर फेवर, राइट, इवन नथिंग कैन बार्क यू, राइट। इसीलिए अच्छा है भाग आप लोग का, कुछ यहां से बाहर नहीं आना चाहिए। दैट इज द नेक्स्ट क्वेश्चन। Case carburizing means addition of carbon over the surface. Carburizing means addition of carbon over the surface. So CO2 नहीं sir, CONO. बाबू जानते हो CO2 is gained when it is unburnt complete combustion. So it is strong. If you talk about CO, भाई साहब unburnt, that is called, we can say what? This is stable, unstable. That's why I am going to use in case of carburizing, I am going to use over the surface of what? A carbon monoxide, and that carbon get entrapped over the surface, and because of that what is happening? Hardness increases. तिवारी जी देखता हूं इसका क्या हो सकता है। So CO you have to be add, not CO2. Question number 132. Which of the following is not the purpose of annealing? Note the purpose. Increase hardness, increase ductility, improve machinability, refine the grain structures. What will be answer? 132. Question number 132 on your screen. Increasing the hardness. Listen, increasing hardness, यार क्या कर रहे हो? कौन अदर ऑप्शन? इंक्रीजिंग हार्डनेस इज देयर ना, हार्डनेस करेंगे हम। हाँ, क्या मैं एनिलिंग से हार्डनेस बढ़ाते हैं? नहीं बढ़ाते हैं बाबा, डक्टिलिटी बढ़ाते हैं, मशीनेबिलिटी ठीक है, लिटिल बिट चेंज होगा, रिफाइन हो सकता है ग्रेन। द क्वेश्चन इज नॉट द पर्पस। ये सब लिटिल बिट हो सकता है यार, इसको बढ़ाने के चक्कर में दिस आज लिटिल बिट कैन टेक्स प्लेस, this little bit can take place. That is not the main purpose, but can take place. But increasing the hardness, never. It never target of the annealing, right? So A for apple is the whichever not the purpose. A is the not the purpose. But here purpose is mainly that, and or you can say the even refining the grain or to so that internal stress is there, it could be removed. इसको हटाया जा सके, internal stress को हटाया जा सके. So okay, 132. You guys have given the correct answer. Question number 133 on your screen. In normalizing operation, still casting, the cooling is done in. Normalizing में cooling कहां पे करते हो? 133. What will be answer of question number 133? In normalizing operation 133, that time everyone of you have given correct answer. A4 sorry C for chain air ना, सही जवाब है, air is the right answer. Good, all of you have given the correct that time. Furnace annealing, okay, furnace will be in the case of annealing, not here. Question number 134 on your screen. Question number 134. I think no, which of the following hardening process result in a change in composition of steel in component? Which of the okay, which of the following case hardening process result in the change in composition in a steel component? Fine. What will be answer of that question? Good question. Question number 134. Better question, and they can enhance your knowledge. And I want to be check how much you have learned till now. So my dear friends, see, in case of carburizing, you are going to use the carbon. In case of cyaniding, you are going to use the cyanide, so surface composition change. In case of nitriding, you are going to use the nitrogen, so surface change. In case of flame hardening, there is nothing I am going to be add here. It is just because of heating, right? So which of the following case hardening could result in the change in composition? 1, 2, 3. Carbonizing, you are going to add the carbon, composition changes. Cyaniding, use the cyanide, composition changes. In nitriding, nitrogen added over the surface, composition changes. But if you talk about flame hardening, it is because of heating, nothing composition going to be changed. So correct answer will be C for Chennai. Here I have written everything. See here, carbonizing, cyaniding, all the things I have written, right? In the, so that you will not get anything problem. I have done all the things here. You can say among the all hardening process, flame hardening, no addition of element. In case of flame hardening, no addition of the element. Okay, only rapid heating and quenching. फास्ट में हीट एंड क्विंच करते हैं, नो कंपोजिशन चेंज, ओनली स्ट्रक्चर, इंटरनल स्ट्रक्चर इज गेटिंग चेंज. Question number 135 on your screen. Which one of the process is used to refining grain of metal after it has been distorted by cold working? फिर से आप आंसर कर सकते हो. You are capable to answer that question now. And हाँ, अगर आप इतना क्लास किए हो, so now don't forget to pay to me. And how you can pay? Just like the session, and if you're interested, you can share with your friend also. But yeah, you can like the session right now. Okay, my dear friends, that's great news coming to you guys. What answer? That time everyone have given the right answer. Everyone now. 135 है ना. Cold working means what you can say? Cold working, annealing, A for apple na. Everyone that time A for apple is given. Chennai, why Chennai yaar? Which of the following was used to defining grain of metal after it has been distorted? So annealing na, distorted means internal stresses, so annealing you have to do, not normalizing, right? So question number 136 on your screen, and yeah, this is the last question of material science. Yeah, please answer that question. It is said that na ant bhala to sab bhala. So answer that question. अगर ये हो गया तो सब हो गया. It is said na ant bhala to sab bhala. 136. Which of the following 100% not generally used for steel? Yes, my dear friends. Great. That time edge hardening. Edge hardening generally for the aluminum or you can say non-ferrous metal. In case of brass, you have to increase the hardness. Then you are going to do the edge hardening. That all are in case of steel. And yeah, you have did the well in the last question. So here we can say edge hardening basically in the aluminum, alloy, copper, or non-ferrous, all that. So my dear friends, in that way the thing is completed. Now if you want to anything, tell me, so that tomorrow I will come. So tomorrow will be our last session of the BEL, right? And tomorrow will be the mock test, as I have told you. And what is Rahul, message करना मेरे को, ठीक है? तो tomorrow join, don't forget to join at 8 p.m. 5 p.m. Write done with the copy, and I will try to revise all the content at the last. And the rest, good luck. Now if you have any doubt, you can ask. Otherwise, thank you. You have, if you have watched all the lectures, really you have a lot of patience. And yeah, I want you to get selected to everyone. Anyone have any doubt, we can ask. Otherwise, thank you for today, my dear friends. Good night. No, tomorrow morning. Tomorrow evening is the session, 5 p.m. No, morning, because already scheduled is there. Morning already scheduled is there, so not possible, Rahul. It will be at the 5 only, because morning na already another schedule is there. Panda, do one thing. I will do the analysis. I will do the analysis of your exam at the 20th of December in the evening. Then once I get the question, then only I could be able to analyze anything about the cutoff. Right now, nothing can be said, Pandaji. Right. So give the exam, give your best, and say me the question of your remember based question, whatever you have remember, batao hame. हमारा आपको मैं आपको व्हाट्सएप ग्रुप दे दूंगा, नंबर दे दूंगा टुमारो क्लास में. Yes, next class I will give the number. Share your memory based question, and according to that little bit I could be able to judge what could be the cutoff, where you have to be challenge the question and option, all that. Meanwhile nothing can be said about that, right? So have you enjoyed material science? Tell me, have you enjoyed, every one of you? So all three important subject you have did: material science, production, and industrial. These three are most important, highly weightage, and fortunately you have completed all that. Then Rahul, then will be more precise ना, जब एक बार रिस्पॉन्स किया आ जाएगा फिर अच्छा है ना, अपने पास क्वेश्चन भी आ जाएगा, चैलेंज वगैरह, और फिर ज्यादा हम लोग प्रेडिक्ट कर पाएंगे. ठीक है, चलो ठीक है दोस्तों, गुड नाइट, थैंक यू, go and take dinner, and yeah, we'll meet tomorrow at 5 p.m. with mock. Don't forget to join that. Right? Thank you all. Thank you.